Hello everyone, my name is Rahul and welcome to my channel DevOps Force. So today we are going to start a series of video on topic Terraform so that you will be able to understand at the end of the series that how Terraform is used, why it is used, when it is used, and also what was the need of creating Terraform as a tool. So this series will be helpful for a freshie or a mid-level expert or a senior expert because we are going to deep dive into the topic or the core concepts of Terraform from beginner to advanced, and we will cover each and everything which is present in the official documentation so that we do not miss anything. And this is the video for 2026, which is going to have each and every topic covered. So these are some of the topics which we are going to cover as you can see on your screen. First of all, we will understand what is IAC and the fundamental. Then we will understand the core principles over there. The next topic is Terraform workflow, where we have core concepts like init, plan, apply, destroy. We will understand how Terraform configuration language is used using the resource blocks or data types, input variables, etc. Then we will understand Terraform expressions and functions, loops and dynamic infrastructure, the Terraform dependency graph, either it is implicit dependencies or explicit dependencies. We will understand the core engine, which is the Terraform state, and the most important topic, where we will also understand some essential state commands. We will configure the remote state and backend. Then we will understand what is code reusability in Terraform, which can also be called modules. The environment management used at enterprise level and very beneficial to understand. The Terraform security, how to secure your Terraform and your credentials. The lifecycle rules and Terraform provisioners. This can be an optional topic, but yeah, it is very important to understand because we are going to cover each and everything in this series. We have Terraform testing and validation. We have some debugging and troubleshooting steps where we will cover the video on how to debug or troubleshoot your issues in Terraform and performance and scaling. So when this video or the series of these videos will be over, I'll be coming up with the next playlist which will have real Terraform projects used in enterprise level, or you can say in the major IT companies. And it will be a deep down to all the concepts which we have covered in this video, and we will be understanding each and everything using the real world projects. And one more playlist I am planning to do. Let's see if it is feasible, then we will create that as well, where I will cover advanced topics of Terraform and advanced debugging and troubleshooting issues, which are actually being faced into the real world, or you can say enterprise level. So let's just quickly start and understand Terraform. So before that, you have a very important step to do, which is you have prerequisites, which you should definitely get it covered. So the first is you should have the knowledge of cloud. So cloud knowledge, it can be AWS, it can be Azure, GCP, anything. Next thing is you should have Terraform installed. So I'm not covering this part because there are various videos on YouTube you can find out, or you have the official documentation as well, how you can install your Terraform. Or else what I can do is I will add a installation.md file into my repository where I will explain, or I can add those documentation where you can follow up and create or install the Terraform, right? The next is you should have AWS CLI installed, right? Because we are going and learn AWS. So this is very important. Next is AWS account. So you should have these four things as a prerequisite, and then we are good to go. So moving on to what is Terraform. So before that, you must have heard that Terraform is called IAC, right? And it stands for Infrastructure as Code. So from where does the Terraform, so what was the need to create this tool Terraform, and how does it started? So let's understand this in a simple way, where initially what used to happen is the developers or the DevOps engineers or the platform engineers or the SRE used to create the or provision the resources manually. So in that case, there were thousands of projects used in enterprise level, and it was very difficult to manage all those 1,000 projects manually, provision your resources, and there were high chances of creating an error or the manual process was slow as well. So there was a gap in the market, and the cloud providers clearly understood that. So what they did, so let's take an example of AWS. So the developers of AWS written a code to create CFT, which is Cloud Formation Template. And Cloud Formation Template is a template where you have code written over here. It can be written in JSON or it can be written in YAML. And applying this Cloud Formation Template, you will be able to provision your resources. So for example, you have multiple resources like VPC or databases or networks. You will write everything here in this template, and you will create an API call from your provider plugin, and then it will create the infrastructure. So this is a very good way to, introduce infrastructure as code, and it was very helpful to the developers. But the problem is you have multiple cloud in the market, and each and everyone is using it differently. So maybe an organization must be using AWS, the next would be using Azure, someone is using OpenStack, etc., etc. So similarly, Azure created ARM templates, which is Azure Resource Manager templates. And then for OpenStack, we have Heat templates, right? So every cloud provider came up with an idea that let's create a infrastructure as code where developers would be able to call the cloud API and create or provision these resources. But think of it in this way. Do you think that learning all these is feasible to someone or to an organization? So organizations have thousands of projects, right? And in this, someone is using AWS, someone is using Azure, OpenStack, K8, GCP. So if a DevOps engineer or to maintain, right, or to maintain an infrastructure, do you think an organization will have some engineers who have knowledge on CFT or have a mastery on CFT, the ARM templates, the heat templates, etc., etc.? So it was very difficult to get a track and learn all these things all at once. So HashiCorp is an organization, it's an org. So they saw this gap, and what they did, they created a tool called Terraform. So what Terraform did is it provided multi-cloud support, right? It was fast. It was not error prone. You will be able to version manage it. And there are n number of benefits of Terraform. So now learning Terraform makes your work easy, right? You'll be able to manage Azure resources, AWS resources, OpenStack, and any other cloud providers or any other infrastructure process. So this thing was very useful when it came into the market, and it was highly acceptable by the organization because it solved a big problem. It also narrowed the gap into the market, and the organizations were happy to accept this. And that is why Terraform is the leading industry tool where every organization is tending to use Terraform as their infrastructure as code. So what infrastructure as code stands for, now you understand it, that writing your code which will provision your infra. And infra means your resources, which can be your VMs, your databases, networks, or etc. Right? So now you understood what is why the Terraform was needed into the market and how it solved a big problem. So Terraform, so I'll write TF instead of Terraform. And this is a keyword for Terraform, right? So what it does, it creates resource dependency graph. Also, it compares your desired state versus current state. And it applies the changes to reach the desired state. Now, let's understand how Terraform works from root level, and let's see how it basically solves the problem. So Terraform uses a declarative model. So now you will say, what is declarative, right? So to understand declarative, we should first understand imperative, right? So think of it in this way. Imperative is, for example, you created a script, a shell script. Okay. You have step 1 to define your variables. Step 2 to create the directory if it does not exist. If does not exist. Next step is you create the backup of whatever file you want to create. And step 4 is you verify your backup. So you can see clearly what is happening over here. So first, step 1 is running, then step 2, and step 3, and step 4. So let's say you did not create the directory. So let's say you have defined the variables and you want to jump directly to the next step, which is step 3. And the directory does not exist. So what will happen? It will clearly throw an error that, hey, your directory does not exist where you want to create a backup and store your file. So this is the error and you need to fix it. Go and create the directory first and then come back. So in this case, what is clearly happening? It is interdependent, right? That without step 2, step 3 is not possible, and without step 3, step 4 is not possible. So this is called imperative coding or imperative graph. Now what declarative is? So Terraform uses this declarative model where what we can say is you have some desire to create an infra or provision the resource. The Terraform engine understand it and it says, okay, I will execute your plan and provision you the infra you requested. right? In this graph, what you can understand is whenever you create or whenever you go to Terraform and you describe what infrastructure should exist, so you do not define how to create it, right? So for example, you do not write the steps like create VPC, then wait, then create subnet, then wait, and then create the EC2 instance. You do not do it like that, isn't it? So what you do in your TFI, you basically go and say, hey, I want a VPC and I want a subnet inside that VPC, and then create an EC2 instance into that subnet range. You do that. What Terraform does is it automatically figures out how to create them in the correct order, right? So this is what declarative basically means. Now, let's understand one more thing, which is Terraform works in three main phases, which is write, plan, and apply. Now, through a graph, we will understand how these processes are carried out. So what you do, you go and create a TF file, right? A TF config written in HCL. HCL basically stands for HashiCorp Configuration Language. Now your config is parsed through Terraform engine. It builds RDG, which is resource dependency graph. It compares your desire with what you have right now. And then it generates the exit plan. Okay. And then the provider plugins you have, it can be different. It can be AWS, Azure, anything. So those are called provider plugins, and it calls the cloud APIs. And then what happens? Infra is created. This is the simple flow, how from end to end you perform actions to create your infra, right? So next, what it does, Terraform communicates with cloud providers using APIs and creates the resources. So in this step, as you can see, provider plugins called cloud APIs. So how it does it, let's understand that as well, which is very important. So the example flow of the API call is, you've written the TF code, right? Now you've written this in your local. Then how AWS will provision your resources? Have you ever think in this way? That have you ever thought of that? Like, I've written the code now. Now what to do? How the API call is being made, how the resources are being created, and how the cloud provider is able to resolve those code and create the resources. So Terraform code which you have written goes to the TF core, which is the parser plus the graph engine, which builds the resource dependency graph, right? And then it goes to the AWS provider plugin, which you have configured into your Terraform code. It makes a REST API call. So for example, it is HTTPS, okay, ec2.amazonaws.com. It goes there, it makes a REST API call, and your provider plugin your provider understand that, hey, it is making a REST API call. The provider plugin is saying, this is the code, I want something to be created, and then it creates the infra. Clear? So this is the way how the internal calls are being made. So API call, how this workflow happens and creates the infrastructure, and then you are able to see or define or manage or provision your resources into your cloud. So a very deep concept is here, which I guess you should understand, and it is very important. So, Terraform builds a resource dependency graph. As of now, you have clearly understood resource dependency graph is a very important thing. And this is the man who is the core person in Terraform, which is handling the creation of your resources. So, what it is and how the resource dependency graph resolves your Terraform code. Now, let's see. So, Terraform internally converts your configuration into a DAG. What it is? What is DAG? DAG is directed acyclic graph. You can Google it, understand the concept, what is directed acyclic graph, come back, rewatch this video, and then we'll clearly understand why I'm talking about that. Let's not deep dive into this topic as of now and concentrate on Terraform itself. So, DAG is a very important thing in Terraform. He's also an important man and he has some responsibility to perform and he does it very accurately. And why I'm saying this is Terraform must ensure that no resource is created before its dependency, the resources run in the correct order, and maximum parallel execution should be performed. That is why Terraform uses DAG, right? So this graph determines which resource depends on which resources can run in parallel, and which resources must wait. So for an example, if you want to create a EC2 instance, will you be able to create it directly? Think of it. No, because you haven't defined the subnet configuration, the firewall rules, or security groups, or your key pair. So these are the resources which are required, right, to create your EC2 instance. So before that, let's take a very basic example. Even before creating your EC2 instance, you want subnet to be created so that you can create your EC2 instance inside this subnet range. And to your subnet range to exist or your subnet to exist, you must have VPC. Without this, it is not possible to create EC2 instance. And it will directly throw an error. It will say, hey, please go and first create subnet, then VPC, then come back and I will be creating your EC2 instance the way you would want. So Terraform understands this, that VPC must be created first, then subnet depends on VPC, then EC2 can be created, right? So this is an example where you can see clearly that DAG or the resource dependency graph is able to automatically understand which resource depends on which, what is the interconnection, what is the interdependencies, and then it creates it automatically. You do not do that. You do not yourself go and say that first create the VPC, then create the subnet, then create the EC2. You don't do that, right? You just declare it. I want these things. And then it creates itself. It manages out, it figures out what has to be created first, and it creates it. This is the way where you can understand the previous concept which I was explaining, that this is automatically handled, managed, or figured out by the Terraform. So this is a one way where it figures out the interdependencies, or which resource can wait or which resource can be created first. The next important topic inside the tag is it follows the parallel execution. Think of it in this way. You want to create a S3, right? So to create an S3, do you think you need VPC? Is VPC required to create S3? Or is subnet required to create S3? Or to your EC2 instance? No, right? These things are not required. But S3 as an individual does not require a subnet range or a VPC or EC2. So let's say you have defined these things into your Terraform configuration files and at the same time S3 as well. So let's take a basic example. S3 needs to be created. You want an S3 bucket so that you will be able to store your objects into this. So what will happen? And at the same time, you have also defined IAM to be created, IAM role, sorry, and VPC to be created. So what will happen is Terraform will do a parallel execution, and at the same time, it will create these three things. This is why Terraform is very fast, because these things are not interdependent to each other, right? These are not interdependent. So Terraform does not wait for each resource to be created first and then to be next. So in this way, parallel execution is handled. So for under that, two things are taken care of: interdependencies and what? Parallel execution. So in this way, Terraform handles or manages your infra, right? So if you want to understand it from the very start, let's do a quick revise or summary of it. So first step is you write your TF files, your code, the resources you want to be created. It builds RDG, resource dependency. It reads the state file. We'll come to this topic later. For now, understand it. State file is very important and it is required. You compare desired state versus current state. Now, generate your exit plan or execution plan and then send action to provider. In our case, it's AWS, right? And then what provider does? It make API call to the cloud and your infra is created. So this was basically how Terraform works. So all these concepts which you see over here is how Terraform works. Internally, the deep concepts, the DAG, the resource dependency graph, how the API call is made, and then how these three phases are carried out: write, plan, and apply. And also, the most important, what is declarative versus imperative. So now you understood, and now you know it very clearly that what is declarative and what is imperative. So let's move to the next topic, which is why we use Terraform. Question is why we use Terraform, right? So first is infra automation, right? So Terraform solves several major infrastructure problems. One of it is without Terraform, what you would have done? You would have gone to or log into console, AWS console, create VPC, and then create a subnet, then instance, and these all things will be taken care by manual process, which is slow and error prone. So this thing is resolved by Terraform. Second is infra consistency. What does this mean? Infra consistency. Now, without AAC, you have multiple environments, right? Dev, test, stage. And this is where what Terraform resolved. This was the biggest problem, where in a project, there are multiple pipelines or multiple environments, right? And in each environment, you have your infra. Each environment, you have your infra. It is very difficult to manage it manually. Process will be slow. You will face a lot of errors. For example, I am creating an infra in dev and someone else is creating in test, and there are high chances of making a mistake by provisioning these resources. So what will happen? Your pipelines will fail, and then you will be in a big trouble. That is why infra consistency is what managed by Terraform, and you can apply these changes to all the stages all at once, right? And what it does, it reduces it. So you will come across this topic or this word quite often in Terraform, which is environment drift. So it does not create the environment drift, rather it resolves it. Next step is version control. You can push your repository to GitHub, which will what it will do. It will track the changes. It will audit your infra. You'll be able to audit your infra, and you can make a rollback whenever you do some mistakes, right? Reproducibility, the most important thing which I found in Terraform and is rep and often ignored is you have a concept of modules, which we will cover later. Modules are highly beneficial for your resources to be reused. It can be S3, anything. So these resources can be mimicked into multiple environments, and you have to write it once only. And in this way, you'll be able to reproduce or reuse your modules, right? Then we have scalability. Scalability is one of the topic where if you want, let's say if you want uh, 10 EC2 instances, right? So will you create it one by one? No, right? Will not create it. So you have a resource block, and what you do is you just add a variable count equals to 10, and it will create 10 resources all at once. So we will come across this count or variables, other things. What are the functions and other aspects of Terraform, and we will understand this later. But for now, just understand scalability is one of the major challenge which Terraform resolved. Multi-cloud management. As of now, you must have understood it very clearly that how Terraform manages multi-cloud. So let's say in an organization, in AWS, you have your compute. For storage, you use Azure, right? And for analytics, you are using GCP. So these all things can be collectively handled by Terraform all at once. So single tool manages everything, which was not possible when everyone introduced their own templatization model, right? OpenStack or Heat, and it had CFT, this had ARM, OpenStack had Heat. This was not possible at all to learn each and every language. Now, seventh point where we can understand why we use Terraform is dependency management. And this is now very clear to each and every one of you that dependency management is handled through RDG, DAV, and how beneficial it is. Eighth is cost optimization. This is also very important. Let's say in your infrastructure, some of the EC2 instances are not working or stopped, or you do not need them. So in that case, the unused servers or unused instances can be detected and it can be destroyed easily, right? Or if you wanted to reapply it, it's fine. You can reapply that as well. One of the other important point which I feel is um, failovers. Failovers. Let's say in a region, US, US East one. So nowadays you must have seen that Middle East war is going on. The US East region was down, something like that. So let's say your infra is in US East one, and due to some reasons or due to some calamities or natural disasters or anything, your infra is down in US East one. What you will do is your infra code is present in GitHub. You can anytime reapply your configuration to some other availability zone, some other region as well. It can be any region, Asia, Pacific, or anything. So in this way, you'll be able to understand or recreate or reapply your infra to the region failures. Right? So for now, we have understood a lot of points why we use Terraform, what what challenges it solves. These are the points. So I'll be creating a notes of it. I will put it as readme.md, or inside each and every day lecture, I will create a folder structure into my GitHub repository, and I'll add all of these resources, whatever we have understood as of now, the lecture notes, and you can go through it, revise it, and then understand it. If you want to come back and watch this video, then watch this again and again, and then you'll be able to easily understand the deep concepts of Terra. Now the thing is sorry, when we use Terraform. So as of now, we have clearly understood when we use it in enterprise companies, IT companies, can be any of the company, right? There are several real world scenarios uh, can be used for cloud infra provisioning, right? You can also do the DevOps automation over here. What it means, you can create a pipeline which checks out your code in GitHub, builds your infra, apply it, which means deploy your infra. You can deploy your application over there, deploy app, and in this way you can create a pipeline and automate your infra provisioning. Right. Third is multi-environment setup. So there's a concept in Terraform called workspaces, which we will cover in the later videos, and you can have multi-environment setup through that, and which is dev, test, and other. Four is disaster recovery. I've explained it before, how company manages it and how you can reapply your changes or infra to any of the recent failovers, right? And at the enterprise level, you have very large scale infra that will have millions or even thousands of projects. This can be covered as well through that, and it is very easy to manage this using Terraform. It is also used in platform engineering, right? And you can also standardize your infra like VPC module or EKS module or database module in this way, right? So if you have to understand this very clearly that Terraform is a wide used tool accepted by the industry, very popular, and also it is very useful. So the platform engineers, the DevOps, SREs, the cloud engineers. So Terraform is useful to all of these fields. I may be missing some of them, but these are the one which I can think of right now. And it is very, very important. So to understand this, you need to understand all of this, because why I've explained this, even some of the videos on YouTube present right now do not explain all of these concepts. They do not deep dive. You know why? Because whenever you are creating your infra, it is highly secured. It should be highly secured. The error should not be, you know, that it cost you a big, and it puts you in a big trouble, right? And it also come up with a cost whenever you are creating an infra, right? And the architecture is very important to understand. If you fail something, for example, in some of the security group, you opened a firewall rule, then what will happen? You will get a compliance audit, and an escalation can be onto you for opening the firewall rule, and it can breach your infra. And what it will do is there will be thousands of security concerns. You may go under attack. Your infra may go under attack. It can cause a lot of problems. So that is why each and every step was very important for you to understand when you do the init, when you do the plan, when you apply each and everything or destroy was very important. And these things, how it works to the root, I've explained it. In the next video, I will explain init, plan, apply, and destroy, but with an example, so that you will be able to see live what is happening under the hood, right? So what init will do to your code, what plan will do, what apply will do, and what destroy will do. So we'll be able to see it live, because when I will run Terraform init, I will show you the internal working of it. So in this way, you'll be able to understand that how crucial it is that we know the core concepts of Terraform and we do not make mistakes. We need to understand the core concepts, and we will meet in the next video. Before that, whatever the prerequisites I have mentioned, please get it done. Just understand all the core concepts, go through the documentation, go through the video again and again, rewatch it, and deep dive into all the concepts which I have explained. So subscribe to my channel for more of these videos, and see you in the next video. So over here, I've cloned the repository, and in my previous video, I've told you guys that there are some prerequisites that has to be done before you move on to the Terraform tutorials. So the first step is you must have AWS CLI installed, which you can see I have 2.34.9 version of AWS CLI. Then I will check my Terraform version, which will be 1.14.7. And also you must have an AWS account, and we are good to go. So all the installation steps I have mentioned in the installation.md file, you can clone this repository and you can go to this particular link and you can install your AWS CLI based on your machine. So for me, I'm using Mac OS, and there is an installation step for Windows or any other system as well. And same goes for the Terraform. Now let's start directly with the tutorial. And first of all, you must understand that to create resources in AWS or any cloud, there are some Terraform configuration files. So first of all, I will create a file called, so I am inside a folder lecture 2 Terraform providers, and I will create a file called main.tf. Now you can name this file as per your requirement, but since this is a standard process which everyone follows, because the main name itself tells you that all the main configuration are present inside this folder. So in this case, you will be able to easily identify and practice a standard process. So writing Terraform code is very easy, but before that, inside your any extension or maybe the VS Code itself, what you can do is you can have this extension which is called HashiCorp Terraform, because whenever you start the coding or write any code over here, so it basically gives you an ease to code. It also tells you that this particular error is there based on your code if you make any coding mistakes, and also it auto fills whatever you are trying to write, maybe it's a subnet, EC2 instance or anything. So I recommend you to definitely download this extension called HashiCorp Terraform. Now let's move ahead with our tutorial. So as you can see over here, Terraform has a wide information or documentation for any cloud provider. So this is called registry.terraform.io, and I have opened it for AWS EC2 instance, right? So when we start any of the configuration file, so the first step, if you remember in our previous video, we told you guys that the first step is to mention your provider, right? So either it's AWS or Azure, whatever your cloud provider is, you must mention it first that you are going to use this particular provider, and then you will be able to move ahead. So what I will do is I will go to Terraform required providers. I will search this, and the first thing you get is you get the documentation. This is a very good documentation, you can read it, and also there is no need to learn code. You can directly go to this documentation and write the code. Even in your interviews, you can use this documentation to write your code, and the interviewer does not mind it, right? So this is the part which I am interested in, and what I will do is I will paste this over here, and let's see how we can move ahead. So what you can see over here is you have a block called Terraform which says required providers is AWS, the source is HashiCorp-AWS, and the version is this, and you have mentioned your region as well where you want to create your resources, right? So over here, if you want to add some more things, you can add it. Like for me, what I am going to do is I can extend this by adding, see, you get your autocomplete steps over here due to this particular extension. So I want to add the required version, and the value would be, I will fetch this from here. So this is the value I want to add, which is 1.14.7. Or else what you can do is, there's a very good way to define this required version, which is you can basically provide an operator and say that, hey, I want my required version of Terraform greater than or equal to 1.5.0, and in my case it's 1.14.7, so it satisfies my requirement, right? And we'll keep this part over here where the AWS version is required now. So in my local, what is the AWS version? Sorry, the command is hyphen version. So it is 2.34.0, right? So even the CLI version is this, I can use 6.0, or because I'm mentioning over here is it should be greater than 6.0 or nearly equal to 6.0. So I'll keep this as it is. And like I said, this is the provider AWS and the region is US East 1. So in this way, you have tell Terraform that my Terraform required version is greater than or equal to this. The required provider is AWS and the region is US East 1. So why provider is very important? Let's just understand this first in a very simple way. So I will go to the whiteboard and let's understand provider. So basically what happens is providers. Whenever you create a TF config, which I'm showing you guys how to write the code. So TF config is Terraform configuration file. It checks the required provider and it contacts to Terraform registry. Now the next step is it downloads the provider binary and it stores this binary into .terraform folder, which will be created after you initialize your Terraform and inside the providers. So .terraform/provider folder, it will store the provider binary which you have defined, right? So the basic syntax could be provider AWS and then your region, whatever region you want to mention, and that is it. So Terraform can resolve your code through this as well. But why I have used Terraform required provider? Because there is a very important concept over here you should understand. So the Terraform required providers, TF required providers, is highly used in enterprise setup because first of all what I did, I mentioned the required version of Terraform, then I mentioned the required provider version and then the region, which was a basic syntax, and we have seen this. So what happens is, let's say for an example, I am using Terraform and I want to set up an infra. Then in that case, what will happen is, if I just directly say that in this provider AWS, in this region, I want my infra. So what will happen is, every time it will basically pulls the latest version, and in this way you will not be able to version it or manage it, because what happens is in every version sometimes a new update comes, or sometimes you have a new set of code or a new way of defining your code. So in that way your enterprise setup fails, because your setup will be used by your end customers or your developers customers or developers or any other person. So in this way, you will not be able to standardize your Terraform config files ever. And every time it will pull the latest code. So for example, let's say 2 years back, I've written some code, right? I've written some config 2 years back. And now uh, it had some particular way of defining the code. But since I'm using this as a provider, then in that case, so this is called basic syntax, right? So this basic syntax will fail because in the newer version, the way you have defined your code 2 years back may not work, right? So which is why to standardize the process of provisioning your resources, we have Terraform required providers where you mention the required version and it will be standard to each and every developer, the customers, or any other person using inside the organization. Similarly, the required provider version and reason is what you can anytime configure or change it. So these two are very important and that is why I have used Terraform required providers. So now let's move ahead and understand the source. So I've mentioned you guys like that source is what uh, you mentioned in the region, right? So the provider source format is in this way. So what happens? There is a proper way in which Terraform understands that how to make a provider resolution, right? So let me just explain you guys in this way that your Terraform breaks down the provider in this way where when you define HashiCorp slash AWS as your source, then what will happen is the registry, it will resolve the registry, which is what? Which is registry dot terraform dot io. Then from HashiCorp API, this is the namespace. The HashiCorp is the namespace, and then AWS is your provider. So this becomes your registry after the resolution. This is your namespace, and this is what provider is, right? So let's go to the code and see how we can configure our Terraform files. So you clearly understood what Terraform providers are, and now you know why we require Terraform required provider. So this particularly is called, let me just add a comment over here so that you guys can understand it. So this is called Terraform required provider block, not a simple basic syntax. Okay. So the next step is, like I said, you have your registry over here, isn't it? Okay. So in this registry, you will find that this is the way by which you can define your EC2 instance or create your EC2 instance. So I will take this one, I will copy this and add this in our code, right? So for example, the resource I want to define over here to my EC2 instance is web server, okay, and the AMI ID could be let's keep it this way only. So AMI is the image which is required so to provision your EC2 instance. So it can be a Linux, Ubuntu, or any AMI image. So definitely the instance type we don't want m5.large, right? So we'll go ahead with t3.micro. We don't need this as of now. We'll remove this. The tenancy is also not required. So think of it in this way. What else is required? So if you remember in our previous video, I've told you that to provision your EC2 instance even manually or through your code, you need a subnet range in which this EC2 instance will lie, right? And also you need a key pair to connect to your or to SSH to your instance. So the next thing which I will do is I will define, see, the key name. So it auto completes it and it is a very helpful extension. So I definitely recommend you guys to install this. And I have a key pair in my AWS account by the name of Terraform examples. So I've created it manually for now. And then the next step is we need to define our subnet ID, right? So how you can get that? Let me show you that as well. So over here you have AWS account, right? I will change it to US East 1. So we are using US East 1 in our required provider block. Okay. So like I told you guys that I have key pairs in my US East 1, which is named Terraform examples. Okay. Now to get the subnet range, I will go to VPC and then over there I'll be able to find out the subnet. So for now it is a basic example, so I will not create a VPC or a subnet. So what I will do is I will use the default VPC, which is by default you get by the AWS. And I will take this one, the first one. So this subnet is inside a default VPC. I will take the subnet ID, and what I will do is I will go and add this into my subnet ID, right? The next step is I want to name my EC2 instance. So for that, I will add a tag, and the tag accepts the values in this format, like key and the string. So I will say that keep the name of my EC2 instance as Terraform EC2 example, right? So now we have got the everything, uh, the every prerequisite to create my EC2 instance. So we have AMI ID, we have instance type, we have key name, the subnet ID, and the tag. So this is the minimal or the basic configuration you have for creating an EC2 instance. Obviously, you can extend it to a very large number of configuration where you have multiple configuration and you can extend this particular resource block. So HCL basically provides this way of coding and it is very easy. Either like you can learn it, or what you can do is you can go to the Terraform registry, and by doing it continuously you will be able to learn it automatically. So for me as of now, like I know that how to write it because it is very easy, and you guys will be also able to write it by practicing. So we'll quickly do one thing. I will do a mistake over here. Let's see what will happen. So I am going to initialize my Terraform directory over here. So basically it similarly mimics how Git works. So whenever you create a new repository, what you do is you initialize the Git. In a similar way, Terraform init, you initialize it. So doing that, you pull some particular providers, you pull some modules, you pull the provider plugins, the binaries, and it initializes and helps you to configure your backend and to version manage it. So when I click Terraform init, it says Terraform initialized in an empty directory. So like I said, I will be doing a mistake over here. And what is the mistake? That I have initialized the Terraform into this directory which does not have any Terraform configuration file. So for that, what I will need to do is I'll have to go to lecture 2 folder. Sorry, lecture 2 folder. Okay, right. And inside this folder, I have my Terraform configuration file. So Terraform will be able to read this file and initialize my backend. So let's say Terraform init, and you will clearly see it says initializing the backend, the provider plugins, and it is finding the HashiCorp/AWS versions matching equal to or greater than 6.0, right? And it is installing this. Now you see there are some files or folders created over here inside my directory. So like I said, in the .terraform/providers, you have some files, right? This is the license. We don't need to read this or understand this. So this is the binary which I was talking about. So this binary is required, and now your backend understand that yes, you want to use a Terraform provider AWS, which is version nearly greater than or equal to 6. So which is why you are able to see 6.36.0. Okay. The next thing is you have terraform.log.hcl. So what it does is basically it stores your hashes from your binary, right? So it logs this particular file so that your backend should not change. So in future, let's say if you want to change something inside your code, and after changing it, you are applying the changes. So it will not change because it has stored that particular hash in this format, and and the provider binary is mentioned over here, the constraints and the versions, right? So this is the important file as well. Now these files and folders have been created. So what we need to do is this particular backend, it configures the authentication as well. So the providers require authentication credentials, and for AWS, authentication can be provided through environment variables, AWS access key ID or AWS secret access key, right? So before creating this file, what you need to do is you need to configure your credentials so that you can connect to AWS account and create some resources. So I have already added the access key ID and the secret access key ID. You can provide the default region name, which I have provided as US East 1, and the default output format, which is I've added the JSON, right? So like I said, this backend will require authentication credentials, which is what I have provided already. So this is very important step where you need to provide the configuration of AWS so that you can connect to your AWS account. Now in this, you can also have multiple providers, but let's not jump into that for now. And you can also provide the provider aliases, so which can basically help you to add multiple providers. It can be AWS, Azure, or even multiple regions, So basically, aliases are majorly used when you want to create your resources in multiple regions for disaster recovery or for any reasons, right? So let's just see what else will be happen in the next step. Now we have Terraform plan, right? But before that, let's understand the Terraform scan concept, where Terraform first scans the working directory for configuration files, which is .tf or .tf.json. So I've told you guys, right? I made a mistake where I was trying to initialize the backend in the Terraform tutorials folder, this Terraform full course, and it was not able to find the Terraform configuration file, and it was failing to initialize the backend. So the example files for that Terraform configuration could be your main.tf, your variables.tf, outputs.tf, and provider.tf. So we will understand this in the later video. But for now, let's see what will happen if I say Terraform plan. Now you see this, that your resource web server will be created, right? So Terraform plan is saying that this is a create symbol, right? If it is a plus, then it means it is going to create some resource. So it will create the web server. It will have the AMI ID, this one, and the ARN is known after apply. So all these fields which you see known after apply is there because we haven't mentioned this inside our resource block. So like I said, you can extend the configuration of your resource to a vast number of extent, which is what you can see all these keys over here. So for now, I haven't mentioned these keys because it could make this example complex. That is why it is saying that whenever I'll apply this, then I will get to know that this particular ARN will be this or something like that. So later it will understand that what are the values over here. I haven't added those values. The values which I have added can be seen clearly over here, right? And these are some of the values as well, which you can see that it is saying false to force destroy, and then it is using the key name which I have provided, the instance type or the region, etc., etc. So these are the things which you can see would be applied, right? So it says plan 1 to add, 0 to change, and 0 to destroy. So as you can see over here that these plan, the plan command is telling you that this particular resource will be created. So I highly recommend you guys that you should go through this um, values or whatever the output you see over here. You should go through this before applying it, because it will tell you that these resources will be created, and it will be highly beneficial for you so that you do not make mistakes, or um, you just cut down your error, right? See over here, it also gives you a note that you didn't use the -out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run. So this is nothing. What you can do is whatever the configuration you have get over here, or so whatever the output you have get over here, you can save it in a file and then use it to apply. I mean, whenever you use the Terraform apply command, you can use that file to apply that resources, and that those resources will be created. So this can be helpful in a situation where, for example, a senior person wants to create the resources, or he and only he have the authority to create the resources. So in that way, a junior developer who is going to who is, I mean, maintaining these code or maintaining these repositories or writing the code, so he does not have the authority to create those resources. So what he does is he do the coding, and then he he saves this output into a file, and then he passes that file to his boss, right? So in that way, the boss will check out that okay, these many resources are going to be created. Are these correct or not? What will be the status of my resource, right? Which is are there any changes, or what are going to be added, what are going to be destroyed? So in this way, uh, you can reduce the errors or any major mishappenings, right? So let's move ahead and directly go and say Terraform apply. Okay, so whatever we have seen in plan action, we can see this over here as well, that these are going to be changed: 0 to change, 1 to add, and 0 to destroy. So it says enter a value. I will say yes. Okay, so what it says, um, mm, 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 on line number 17, what has gone wrong over here? Okay, so the image ID is what he is saying, that it does not exist. So it actually, what it does is, um, I have pulled this code from the Terraform registry documentation, and many of the people have used this AMI ID before. So what we can do is, I'll show you one more thing. A better way to get this AMI ID. So let's do one thing. I'll go to the EC2 instances, and then let's try one thing, that I want to create EC2 instance, and from here I want to get the AMI ID. So in this way, you can also get the AMI ID, the fresh AMI ID, which is not stale or which has not been used before. And what I will do is, I will add this over here, and let's reapply the command. Let's enter yes. Now it says the web server is creating, right? So meanwhile, it gets created. Over here, you can see that you have a file called terraform.tfstate.log.info. You have a terraform.tfstate, and you have terraform.tfstate.backup. So, oh great. So the resource has been created, 0 change, 0 destroyed. Let's see in the console. Okay, I was not sharing my screen, sorry. So these were the file which I was talking about, terraform.tfstate and terraform.tfstate.backup, right? So uh, let's check whether my resource has been created or not first, and then I'll explain you a concept of what is tfstate and tfstate.backup, and why is that it has been created, right? Inside this instances. Oh, great. So the tag which I have given, Terraform EC2 example, it is taking the name of that instance as Terraform EC2 example. The instance ID is this, and it is in running state, right? So we have this EC2 instance provision in our AWS account. Now let's understand one more thing. We have seen that there was two other files when we applied the change, which was terraform.tfstate and terraform.tfstate.back. So basically, Terraform, oh, 1 minute. So Terraform state file basically have the state of your configuration which you have applied, right? So Terraform keeps track of all resources it manages in a file which is called Terraform state, right? This Terraform state have resource IDs. Whatever the resource you have created, those IDs will be present in this TF state file. The infra metadata, right? So the infra metadata is what? Your resources metadata, and then your dependency relationships. And then also it has the current infra state. So these are very important things which basically Terraform state files have, right? So similarly, in this way, what happens is it creates a backup automatically of this particular TF state file, because like I've said, this is a very important file which maintains or which stores the state of your particular configuration. So that is why we need one more concept, which is Terraform TF state dot backup, right? So let's say you have your Terraform dot TF state, and it is the old state, right? So it gets copied to your terraform.tf state, terraform.tf state.backup file, right? And then your new terraform.tf state is there written after you apply, after you say terraform apply, right? So this way, whenever you apply the changes, there is a mechanism where it automatically have the old state, it copies the old state of your tf state file to your terraform tf state.backup, which is very important. And this new terraform tf state is written after the terraform apply, and the old state remains into your terraform.tf state.backup, right? So in this case, if something goes wrong, the backup contains the last known working state. So you must be thinking that why Terraform does this, why it creates this terraform.tf state.backup. So it protects against the state corruption, your interrupted Terraform apply, or manual state modification errors. So for example, someone, you have created this particular configuration and you have created your resources, and someone is going has gone to those resources and made a manual change. So in that case, what it will do is it will also save you from creating a manual error or manual configuration change, right? So like I said, that the terraform.tf state.backup have your old state, and it gets applied, the old state gets written to your terraform tf state.backup whenever you apply the terraform. So what is the use of it? In real projects, we do not store state locally. So instead we use remote state, such as AWS S3 or your Azure storage or your Terraform cloud. So in this case, it will be helpful. So now you understand four things clearly, which is your provider. You have Terraform required providers, which is very important, right? Instead of the basic syntax, how to write the code, how to create your first EC2 instance, right? Now you understood what Terraform .terraform folder have inside it, the vanity hashes, the log, etc. The TF state, I'll show you the TF state as well. So see, you have your AMI ID over here of your instance. You have the availability zone. So these were the state I was talking about. And similarly, there are n number of configuration which you can have inside a Terraform resource, which will be preserved over here into this .tf state. And we didn't add any ephemeral block device or anything. So see, we saw this, right? Configuration when we use Terraform plan and apply. So all this information is stored into the tf state file. And we have Terraform state backup as well, where it says that it has some particular fields over here, and it has the Terraform version, the lineage, the outputs, resources, etc. So whenever I'll make a change in this code, the next time what it will do is it will store this state, this particular current state, to this one, terraform.tf_state.backup. And when I will apply the new change, then the new change will be overwritten to this file, terraform.tf_state, and then the terraform.tf_state.backup will have your old state, right? So you have understood Terraform init, plan, and apply. One last concept is Terraform destroy. Now let's see what will happen when I say Terraform destroy. So it is saying that I'm refreshing the state of your EC2 instance, which is web server, and it is showing me that these things will be destroyed. So similarly, when you say Terraform plan or Terraform apply, it has a plus symbol over here and says create. In the same fashion, when you say Terraform destroy, it will have a minus sign, and then it will say these resources will be getting destroyed. So these are the resources which is going to be destroyed. So it has pulled all the configuration like the ARN ID, the AMI ID, or any other configuration. And the minus symbol over here signifies that it is going to be destroyed. So it says plan 0 to add. So there's nothing to add, right? 0 to change. There's nothing to change. We are not updating anything. And 1 to destroy. So which is what we are destroying. I will say yes. And let's see what it does. Okay, so it is destroying my ID. So it ends with ECA, right? Let's go and check our instance ID, and it says ECA at the end. So this is the particular instance which it is going to destroy, right? And I think it has destroyed already. Let's check that. Okay, it's already taking some time. So meanwhile it does that. Okay, it's destroyed. So now you have understood the core concepts, how the workflow works, right? How the provider block is written, how it makes the API call, what are the provider plugins, what are the provider binaries, how it locks that particular binary. Okay, and then also you have understood that how plan will help you, how apply will help you to create the resources, and etc. Let's just refresh this, and I don't think we'll be able to find. Yeah, it's terminated. Okay, so this was it. Now, Terraform is written in Go language. So, let's start from here that Terraform is written in Golang and its config files are written in HCL. So far, you know what HCL is. And then, so the HCL is designed to be human readable, and it is declarative. You know it very well now. And then it is structured and also parsable by machine, right? So if I take a basic example, so in our previous video, you know we have created one EC2, right? And we have defined a resource block over there. So the general syntax of Terraform is the block type and label. 1 and then label 2, and then we have argument and value, right? So the first thing is this block type can be called as resource or outputs or data or variables. So this is a resource type which you can say for block type. And then in the label one, we have what type of resource you want to create. For our example, in our previous video, we took AWS instance, right? So this is resource type. And then we have resource name. So this is the resource name which is going to be recognized throughout your code. So for example, if you have named this as web, then in that case you will call this resource, this particular block, in your configuration language, in your configuration file, through web only. And then we have argument and value, where you can have multiple argument, but in our previous case we had instance type as an arg and t3 dot micro was the value, right? So the core components of Terraform configuration are resources, data types, variables, locals, and outputs. So all of these work together to define your infra. Now, the next thing we need to understand to learn HCL language is resource address. Now let's see. The format of calling your resource is resource type dot name. Like I said, when you have created any instance or any resource, so these resources should be, or you may want to call it or use it or reuse it in your configuration file. Or let's say you have created a security group, right? Let's say you have created a security group, and this security group needs to be used by our EC2 instance. So in that case, the dependency is there, and this security group should be called by EC2 instance so that the firewall rules can be added in this EC2 instance, right? So the resource address, which means how your resources are going to be addressed in your configuration files, and the example could be AWS instance, which we created in our last video, and .web server, right? Now the next topic is arg versus attribute. Okay, now values generated by the provider after creation is called attribute, and arguments is values you define in the configuration. So the argument could be instance type and t3 dot micro, right? So this is argument, and attribute could be your public IP, your ARN, or your ID. So understand this in this way. The attribute is like you have created an EC2, right? So once your EC2 is created, it will have a public IP, it will have a ARN, and it will have a ID. So if you want to address or use these public IP or ARN or ID or reference it in other resource blocks or other resources, then in that case, the attribute is the one which is taken care of, right? Now the Terraform data types, we will understand it, and Terraform supports several data types, and we have some examples over here. So this is the string, which I think we should not discuss it, because string, number, boolean, these are the data types which you will see in all the programming languages, and it is a very simple one. So let's just quickly understand this, that the type is equals to string. When you provide this argument, then it will behave as a string, right? And the usage could be this can be used as a tag inside any of your resources, right? Now you have the second thing, which is number. When you want to define the instance count, let's say you want to provision EC2, and this has to be two instances, like you want to provision two servers, right? So in that case, number is helpful, and boolean, of course, you know, either it can be true or false. Now let's understand set, because this is a bit different, like how it behaves in other programming languages and how it behaves in HCL. Now understand this thing. Terraform does not support directly accessing elements of a set by index, because sets are unordered collections. So to access elements in a set by index, you should first convert the set to a list. So this is our set, right? Now what I have done over here is I have converted it into a list. So this is a list, right? So this particular set is converted into this list because Terraform does not support directly accessing these sets, right? So you will use the toList function. This is the toList function, which is used to convert the set into a list, right? And the example is this one. Now you can then reference an element in the list using this format, right? So as you do it in other programming languages, like for example in Python, you can access the list now through the indexing, right? So this is very important. You need to understand, whenever you are defining a set inside a Terraform configuration file, then you must take care of one thing, that using the toList function, you need to convert the set into a list and then access those elements or those values through the indexing part. Now let's understand list. So this is also a very easy one, like you have used before. So you can use a list of values. Over here, if you take this example, we have variable as an availability zones, and the type is list of string. Okay, so these are the two availability zones I am taking over here, and then how I am accessing it through indexing. Like this means it will pull US East 1A, right? Similar to what we have seen in Python. Now we have map. A map stores key value pairs, right? So the example could be this one, where you see over here is tags. So I am taking the map of strings and I have added key value pairs of environment equals to dev, and the project is Terraform demo. Now the usage could be, you can use these tags inside your resources, and you can segregate your tags. Like if it is for dev environment, then it will place those tags into those particular resources. If it is production or it is staging, then it will configure those accordingly, right? Now we understand objects. So objects allow structured values, right? And the example is this one, where I have defined the type as object and instance type is string and volume size is number. So EC2 instance type would be over here is string. So I can say t3.micro, and the volume size could be a number. For example, I want 20 GB of storage mounted to my EC2 instance. Then this could be helpful, right? Now we will understand tuple. So tuples are a type of complex data structure that allows you to group multiple values into a single value. They are similar to lists but have a fixed number of elements, each with its own type. So the example could be this one, the server config, where the type is itself object and we have instance type string and volume size number, right? I think I have copied the wrong one from here. Let's see. I guess this is the one for tuple. So these are the lecture notes. in the GitHub I have placed, and I'm taking these examples only to explain you guys. So by mistake I have copied the object one, so sorry for that. I mean, let's change it and paste it over here. So this is the one. Like you have defined type object or string or list. Similarly, you will define the type equals to tuple, and then we have string, number, or boolean value. Now understand this very clearly and take a note of this, that elements of list, tuple, and map values can be accessed using the square bracket index notation. Like I said, you seen over here, this is called square bracket index notation, right? So sorry. So this is called square bracket index notation. Let's add this like this, square bracket index. So this is an SBI notation. Okay. So like this example, you can access the elements of list, tuple, and map values. Okay. And the expression within the brackets must be a whole number for list and tuple values, or a string for map and object values, right? So object allows dot notation also. Like if you want to call your elements of any object, then you can call it by using the dot notation as well. So this for example, let's say I want local I will explain this later. I want local to call server configs this element instance type. So I can use dot instance type, right? So there are two ways to access the objects elements. First is dot notation, and the second is square bracket index notation. So in both the ways you can access the object. Now you understood this one. Okay, so you must be thinking that in all the other data types we are using a specific way to access the elements of that particular data type, but why it's different for object, right? Why bracket notation is sometimes preferred, or why, I mean, Terraform has given a special power to objects, right? So if the keys are dynamic or user defined, so dot notation may not work. So let's say, for example, in your locals block, what you did is you added a user tag, okay, which is your project name, and it is Terraform practicals, like this. Okay, so dot notation, this dot notation will fail over here because you can see this hyphen, right? So if you want to access the objects through the dot notation, then in this case the value over here will not be fetched because you are using a hyphen over here. And in some of the projects, these are the standards, or the standardization they use for their convention, right? So the project name contains a hyphen. That is why in this case what it will do is we can use the SBI, which is square bracket index notation. So in this case I can access the project name in this way, right? You have understood this part. So let's move ahead with the next thing, which is input variables. So variables make infrastructure dynamic and reusable. So many a times you have seen over here that I am using a concept called variable. So this variable is helpful to make your infrastructure or your config files dynamic and reusable, so that you can access these variables, or you can define these variables in a different file and then access this, so that you can repeat the number of accessibility of a particular variable inside your Terraform block, similar to what you have seen in other programming languages, where we define a variable and then we use it in multiple areas and we define it once, right? Now we have variable validation. So Terraform variable validation ensures that input values meet specific constants before applying configurations. So preventing misconfigurations and improving reliability. You can enforce, let's just add the topic name first, variable validation. So like I said, the variable validation ensures that input values meet specific constants before applying the configurations and preventing misconfigurations and improving the reliability. So you can enforce rules using the validation block inside a variable definition. So if I take a basic validation example, there are various ways of validating. So I'll be covering this part into my next series, or I'll make a dedicated video upon this. So what are the best practices using this variable validation and what are multiple types of variable validation, right? So for example, I am defining an environment, right? And I'm saying the type of this environment is string. I'll add some description that this is my deployment environment. Okay, just a minute. And then I will add a validation block. So this is what I was talking about, and this is an important part where I will add a validation block and I will write a condition that the deployment environment should contain dev or staging, right? And I will take the environment value through my variable file. Okay, so like I was saying, this variable, for example, I have defined environment over here as a variable somewhere, and I've said add a value here which is what? Dev. So I want my deployment to be done on dev environment. So in this case, what this validation will do, it will basically checks this condition that whether your particular variable environment, this variable which you have defined before, contains dev or staging, right? And then if the condition is fulfilled, then it will do the deployment. Else, let's say if you have added production over here, then what it will do, it will basically fail over here and say, and give you an error, right? That the value of the environment is not dev and staging. So you must change it to dev or staging, right? And one more thing over here is, let me just add this. You can also print the message that environment is not equals to dev or staging, right? You can think of this like the try-catch exception which we use in Java. So in similar way, this is the one where we are catching the exception, we can say, which is the error message. And you just take the example of Java just for your reference to understand this. But this is how you do the variable validation. Now let's move ahead with another topic, which is variable sources, right? So variables can come from default values. The default values, if you define it inside your configuration file, it can be come from your tfvars file. I'll explain this. What is this? And CLI variables as well. CLI means, for example, you have added Terraform plan or Terraform apply command, and in that case, in your command line interface, you will be prompted to add the input, right? And it can also be environment variables. So these are the type of variable variable sources, right, which we can define in Terraform. Okay. The next important thing is locals, right? So far what we have understood, multiple data types, right? And why set is uh, converted into list, and then we access this using SBI notation, square bracket index notation. And object is a special case where it has two ways of accessing the elements. First is the dot notation, this one, and the second way is second square bracket index notation, right? Now, then what we understood? We understood variables, then we understood what is variable validation, and then we understood variable sources. Now, locals. So locals are basically temporary values used within Terraform configuration. So they basically simplify the complex expressions, and you can use it in your main file or any other files, but majorly it is used in main file. And this local is defined in such a way that environment equals to dev, and you have instance name. So from this example, it will get clear that why we use local. So let's say I'm using local dot environment to reuse this as a instance name, right? So these are short-term, short-lived or temporary variables which are used inside your Terraform configuration files. And the benefits is you can avoid repetition through this, because once defined, you can use it in any of the resource blocks. You can compute the derived values. In this example, local dot environment, I'm using the dot notation to access this local dot environment. So throughout the Terraform, you can access the variables through dot notation, but there are some cases where the square bracket index notation is used, and which I have told before, right? You can compute the derived values, okay, and then you can improve the readability of code. Right? Now let's understand one more topic, which is outputs. Okay, so outputs is basically whenever you have configured your code, you have written all your configuration and all your resources blocks and everything, then what will happen? You want to output for example, the public IP of your EC2 instance, or the ARN, or the ID, or any other configuration. So in this case, outputs exposes the information after your infra, this is important, after your infra is created. Now, I will take this example in the code part where we'll take an example code and we'll understand what is outputs. But for now, just understand this. If you want to access any of the configuration from your resources after the creation, then in this case, you can use outputs. Okay, so outputs are useful for displaying your infrastructure info and passing values to modules. So there is a concept which is called modules, which we will understand later. But just for now, understand this. You have some of the configuration files and you have added the command terraform apply, and it produces some outputs, right? So these outputs can be fed into your modules as an input as well. So for example, module 1 produces some output, okay, and module 2 is there, and this module needs to fetch some of the output from here, from module 1, to get applied or to provision the resources. So this output will be passed to the module 2 from module 1, and it can be reused. And also you can integrate with other tools as well, but let's not understand that. So there's one more important topic, which is Terraform file structure. So from now we are not going to add all the configurations into a single file, which is called main.tf, because that is what we do not follow in the enterprise world, or you can say that is not a standard process. So there is a process through which you can structure your file system in Terraform. So we will deep dive in advance how IT companies structure their Terraform files in the later video, or I'll make a separate video out of it. But for now, just understand the basic so that you'll be able to understand that how today we are going to use the example code and add the configurations. So we have, first of all, providers.tf. The name itself suggests it will have the provider configuration, and Terraform should use it and authenticate you through your credentials, right? Second is main.tf. So far you understand that what is main.tf clearly. It will have your main configuration, actual infrastructure logic. Okay. Third is you have variables.tf. So we have discussed so far what are variables, right? So all the variables are added into this particular variables.tf file so that we can reuse this in our later configuration files. Okay, so it defines the input variables and it allows us to make the configuration flexible. So instead of hard coding the values, variables allow customization through your external outputs, right? Next is we have tf-vars file. So what is tf-vars? Basically, the tf-vars files are used to assign values to variables. So you have variables.tf file over here. So you have some particular variables, for example, variables configuration inside this, and you want to pass the values to these variables configuration through this tf-vars. So where it is used, I mean, how is it helpful to the variables.tf? Because let's say, for example, you have multiple environments: dev, test, stage, production. And in this case, you have one single file which can handle these values, and these values could be passed into the variables configuration. So in this way, what flexibility it will provide? You will not need to change your variables.tf again and again, no configuration change. So think of it in this way. So let's say I have this file structure and my variables.tf have one variable which is called environment, right? So if you want to deploy your application into dev environment, then you will add the value as dev. Before that, you will say that type is string, right? And if the next time you want to deploy your application into test, so will you go and change this again and again, like add the value the next time you do it for test, the next time for stage, the next time for prod? Will you do that, or is it feasible? No, right? So in that case, what will happen? You have a single file, make changes to this one, you make this standard, which can be reused in your configuration files, right? And the last one is outputs.tf. So outputs allow Terraform to display useful information, like I said, after resources are created. So let's just quickly go to the top and revise a little bit, and then we'll directly jump into the example code. So understand this. First thing, Terraform is written in Golang, right? And the configuration files of Terraform is written in HCL. So HCL have human readable, it is declarative, structured, and parsable by machine, right? We understood what is the general syntax, how Terraform behaves with this general syntax. So we have the standard like block type. It can be outputs, resource, data, and variables. We have seen this, and we have arguments and values over here. The label one is resource type. The label one is resource type, right? Which type of resource you want to define in your configuration file. And the label 2 is resource name, like web server or example server or anything, which will be later addressed or referenced into your further resources. The example I've given you is security group, which is like EC2 instance, which is dependent on security group, and these values will be used through EC2 instance. Then in that case, the dot notation, using the dot notation, you could be able to call the security group inside your EC2 instance. Then we understood what is resource address, right? And then we understood arg versus attribute. Attributes are after the creation of your resource, whatever configuration you want to fetch or you want to reuse it in your configuration file, those are attributes. And arg is, we know that clearly, right? It is instance type, and t3.micro is one of the example over here. We understood multiple data types, right? And then we understood what is variable validation, and variable sources. These many are the variable sources, and one of them we used is Terraform TFVops, right? And we have explained that what is TFVops file, and you can also add any name before this dot notation, but this is a standard process where many of the developers in the industry use Terraform.tf, right? Default values is directly inside your variables.tf file. You can define the default values. The CLI variables are when you do the Terraform apply or plan. So in the command line interface, you will be prompted to add some input, and the environment variables is what you can set inside your configuration. We have locals, which are temporary block and temporary values. So these are short-lived values, and this can be reused and is beneficial when it comes to avoid the repetition, the derived, and we can use these derived values and improve the readability of code, right? We have outputs. I have explained it very well. Then we have Terraform file structure, which is the most important, and in our later videos we'll cover it in advance, right? So these many are the concepts which are basically very useful for you to code in HCL. So these concepts will help you to write your code, and just like in Python or any other programming language, you first understand how to write the code, what are the data types, what are the sources, etc. Similarly, today we understood how HCL is written, how we write the HashiCorp configuration language into our Terraform configuration files, right? And like in Python or any other programming language like Java, we call some of the variables. Similarly, we call it in HCL as well. Now just quickly jump onto the code and understand this through an example. Okay. So I will go over here, lecture 3, and I have added these notes. So I will add the GitHub repository URL in the description. You can understand all this which I have explained, right? So I'm inside the folder lecture 3. So quickly, what I will do first, I will add the providers.tf file, right? First step is what you do, you add the provider, which provider you want to use, which cloud you want to use. And I told you, you don't need to learn it, how to code. Just go to the web and say Terraform required providers. First one is the Terraform registry. This is very helpful registry. go through it, read each and every code, and you will be able to learn it very quickly, and it is very easy, right? So before that, I will add that this is the providers.tf file. So the autocomplete is what interrupting me, right? We understood this before, what it is, so don't need to repeat that. I will add the required version, which can be greater than or equal to 1.5.0. If you want to understand what is providers, then you must watch the previous videos. So now this is done, right? We don't need to add something else over here, but we will make a change for sure, because today we are understanding how to write the code, and the best way to write your code is dry, right? Don't repeat yourself. So the dry is the concept where you don't repeat yourself. So I will do not hard code any value, and I will standardize it, but we'll do that later. For now, let's create the most important file, which is variables.tf. It will have all our variables, and you will understand that how we write the variables. So I will add one by one example how using the data types. So these are the data types which we understood. So I will add one by one comments for these data types, so that you can understand it one by one, how it is used into the configuration file and why it is useful. Okay, so let's add a comment that this is my variables.tf file. Oh no, the auto completion is okay, so let's forget that. So I will give an example of string, where first thing I told you, we will not hard code anything. So in this case, AWS region is what you want to define, right? So AWS region is type. Like I said, you need to define the type of the data type you are using. So in our case, this is what? This is our basically string data type, right? And description I could give over here is define your AWS region. Okay, so now we understood. Next thing is, we understood the number data type. So quickly I will add the instance count. Okay, so basically I want two instances of my to be running on my AWS account. Okay, so type is, so far you have now understood. See, the auto completion itself is telling you or suggesting you that what you can use over here, and description I can add is the number of instances you want to define, right? Next thing, let's move ahead and understand what is Boolean. Okay, so let's say for my EC2 instance, I want to enable monitoring, right? So in this case, I will add the data type to be bool. Let's just remove the space here, and description is enable or disable monitoring. Okay, so let's move on to the next topic quickly, because this will take some time. Okay, what I did, yeah. So list, we have list variable. So what I want is, in our example, like we took the example of availability zone, same example I will take over here, availability zones. So this is a very basic syntax if you see so far. That is why I'm able to write this code without even going through the documentation. The type is, if you remember what I have explained, you need to add the type, and we will add list of string. right? And all these values, if you see all these variables which I have defined, I am not adding it any value to it. So if I would have added any values over here, then it could be an example of input variables, right? And today we want to take examples of tf wars file, right? So next is set. Let's quickly move ahead and add that. So for set, let's say mm, 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 let's say for my EC2 instance, I want to allow some ports to access, right? Later I will add that it could be the 22 for SSH to open the SSH tunnel so that we can access our EC2 instance, right? Now you got all this configuration. The next we read was set, till set I remember it. We have used list. Now comes map, object and tuple, right? So quickly just use the example of map, where basic example is you can use tags, right? And it what map does, it accepts values in the format of key value pair. So first step is add the type of the variable, and then let's keep it aside. We do not need to add description for each and every variable. You will be able to understand it, right? And for object, okay, what I am doing wrong, variable, okay. So let's say for objects, the example which we took is server config, right? So what I will do, I will copy this and add it to my code. Don't need to write each and everything. Okay, something happened. Yes. Type is object. I think they want us to write. So let's do one thing. I will remove the trailing spaces. Let's add this in this way. Volume size. Now we are good to go. Last thing is tuple, right? The variable. You can take any example, like let's take example tuple only. Let's say the tuple. Wait. Let's frame it in this way. Tuple example, and it accepts what kind of what kind of value? Sorry, tuple. Okay, and the multiple values could be string, your number, your pool. Okay, and the last block is for variable validation. We can also add this variable validation. So you add environment, the same example I'm taking, which I took in the whiteboard, which I have explained. Type is string and validation. So what is the validation I want to put, right? Condition, sorry, condition is it should contain contains dev or staging. Okay, I think I missed something. It is saying wrong. Let's see what is the error. Required attribute is this. Okay, there is one more mistake over here, right? Staging, and we take one more input. So this we will take from the tf file. Okay, I think, okay, this one is the part where I'm missing something. Okay, now let's add the error message that environment must be dev or staging. That's it. So you understood, right? These are the data types which we understood, and we are using it as an example over here. Next thing is you want to pass the values to this particular variables.tf file. So in that case, what I've told you, you will need terraform.tf parse file. Now I will add the AWS region and see it is giving me auto completion. I will say US East 1. Now instance count, let's keep it 2 and enable monitoring, and it was Boolean, right? If you remember. Next thing is availability zones, and first we had US East 1A. The next we had was US East 1B. Okay, these are the availability zones where I want to deploy my resources. Now what will be the allowed ports? Let's see, AWS region, instance count, monitoring, availability zones is done, allowed ports. Okay, so this is what I've said, that for my EC2 instances, which ports should be allowed. Okay, so I will do 22, and let's say one more is I think for MySQL we use 3306 MySQL port. Yeah, 3306. Okay, so let's say I want my instance want to connect to the database database as well. So we'll allow 3306, right? Next, common tags. Okay, let's copy this, add it over here, and let's say common tags will be add the name of my project as Terraform data types, and let's say owner is Rahul. Okay, next thing is, let's see, common tag server config. Okay, so this is what we need to define next. So for server config, I told you instance type t3.micro. Of course, we don't want to get billed heavily. And then we have volume size, which was what? Let's take a small example of 8. Okay, because if the volume is higher than 8, you will be billed heavily in AWS. And the example tuple we took, list. Okay, yeah, example tuple. So tuple example. Sorry. Now we have what? We have added which values over here? One was string, one was number, one was bool. Okay, so I will say tuple example, boolean is, second was number. I will say 10, and let's add true to my value. This is done. Next is environment, right? So environment is dev, of course, and then everything is done. Variable validation is so this is not what you define in terraform.tf first, because this is itself a condition check. It does not include any values, because this value will be taken from the environment itself, which is over here. So if it is prod, then it will fail with the error condition. Otherwise, if it is dev or staging, then it will pass. So Terraform automatically it will load this .tfvars file. So Terraform reads the file structure and it sees that, yeah, so you have this terraform.tfvars, which means the person wants to use this file, and it automatically loads it. You don't need to pass or pass this file to any CLI or take any output from here. Next is the important file, which we have main configuration file. Okay, so over here, I said we will use locals, we will use a resource block, and we will also see how we can access these variables inside our main file, main configuration, right? So first thing comes is first thing is locals, right? Because these are short-term or temporary values which we will be using inside our configuration. Okay, so we want to add the name to our instance, and you know it so far that it is a string value. So from variable file, what we will do from this file, what we will do is we will take the environment variable. Okay, where it is, somewhere around here, I guess. Environment is also, yeah, this one. So this is what we took, right? So what we will do is this is the environment dev. Okay, so I want to name my instance by the name of the environment so that I can segregate my instance clearly. Okay, so I will use var dot environment, right? And I will say this is a web server, right? So just for now, not to make the example complex, I will take only one instance, because for using it, like, what it will do is, if I will take two over here, so then in that case what it will do, it will create two instances by the same name, var.environment web server, right? And you will get a little bit confused. So in later we will understand that how we can use the count to define multiple multiple instances with different names. But for now, just take a simple example. Now let's do one thing. Let's see what we can do from here else. So we had the common tags, right? So for sure, when I have named my environment, my EC2 instance by the environment name, so what it will do, it will say, if the instance will be created, it will say dev hyphen web server, right? So similarly, we have also common tags which we have defined over here, right? So we want to tag our instance so that we can clearly identify our instance, either it is of dev or staging. So let's do, what we can do is instance tags. We can say instance tags is merge. We are using a merge over here. In the later video we'll understand what is merge, because why I'm using is, I want to add the tags and merge it. So let's say the name is local dot instance name, right? This one. So you see how I have used the locals block, right, and reused my instance name over here. Okay, there's some error. Let me check what it is. Okay, let's see. So merge takes an arbitrary number of maps or objects and returns a single map or object that contains a merged set of elements. Let me check what I did wrong over here. Common tags. So what it does is, it merges the set of elements. Okay, so for merge we haven't used the first what you can say, first variable or first value. So we told you, right, that we are going to use common tags, right? So this is the first value and it will be merged with this one where I am myself doing two things over here. So let's understand this. It's just okay. So I am merging this tag, right? The common tags, which is the project and the owner. Second thing is I am adding the tags, which is like to give the example of local, how we can reuse it, right? So what it will do, it will take the instance name and add over here as a tag and the name. So what it will do, basically it will name your instance by local.instance name, which is what dev-web server. Okay, so next thing is let's just quickly add the environment as well. So let's say environment is the variable name and we are taking it from var.environment, right? So if it is dev, it will add dev as the environment name. Now next thing is we want to use, okay, let me just not confuse this with this one. Okay, so locals is closing over here, locals is getting closed over here, right? And okay, cool. Right, now next thing is we will say the tuple example which we took, right, over here. After this we had tuple, so let's take a tuple, what name we can add, tuple instance or something like that, right? It doesn't matter the name. Okay, so var dot, what was it? It was tuple example, and I've told you guys we will, for tuple we access the elements using square bracket index notation, right? And now we have list as well, by the name of tuple. I remember list was also there. Yeah, this one. Okay, so the rule which I've told you, first let's do one thing, let's name the variable first, and then if you remember I told you that for list, sorry, this is what set, right? Yeah, allowed ports, and we are using ports. So for set to be parser, like to the Terraform parser, so that it can understand, you first need to convert your set to a list, isn't it? So to convert that, what was the function? To list, and we will use allowed ports, correct? Now we have resource block which we will define the AWS instance. It's same. Let's name it web. Okay, and the count which we used, which is var dot instance count, right? AMI ID is the thing which I will fetch it from here. Okay, I don't know which one it is taking, so it doesn't matter. I will just take the AMI ID from here. In our previous video we took AMI ID, right, from this example. Let's just yeah, it's loaded. Now quickly add this one. Okay, we have AMI. Now we need to tell what type of instance, either it is t3.micro or t2.micro. So for that, what we did, we used server config, right? Server config, isn't it? And then the instance type. Okay, for monitoring we used enable monitoring. right? For availability zone, you remember it very well. We used a list. So we will use the availability zone. Okay. I guess it's zones. And we will take the first one. Again, square bracket index notation because it is a list. For block devices, what we'll do, we will add the volume size. Let's say it is var dot server config. If you remember, inside server config, we had two values, instance type and the storage type, storage volume size, sorry. So we have volume size. Now let's do one thing. For tags, let's just reuse our local block. And what was the tags which we added? Instance tags, right? Let me see this one. Yeah, instance tags. So I want to add the tags as well for my EC2 instance. Instance tag. Cool. Now we have everything over here. Okay. The last thing is we want outputs.tf. Outputs.tf. Let's just quickly add this. Let's output the instance ID. Let's say. And how we can do this? Instance ID, if you remember, we used what? For instance ID, let's see. I think we used a list, right? So let's take that one example. AWS instance dot web dot our ID. Okay. Now let's quickly move ahead with the public IP as well, because you want to connect with your EC2 instance. Then in that case, you will need your public ID, and the value would be same AWS instance dot web, and we will take this one. Sorry. Okay. Dot public IP. See, so these are predefined variables which you get after you create the resources. We have next thing is allowed port. Okay, so let's say if you want to check which ports are allowed for your EC2 instance, then quickly just do one thing. Take this one. And why I'm using local? Because in our main.tf we are using local to add the ports, right? Somewhere around here. Okay. So the list is, the port list is inside our locals. So which is why we are accessing this particular allowed ports through the local values. Local dot allowed ports. And again, something is missing, I guess. Okay, same name I have added here, so it should be allowed ports list. Now what is the issue? No declaration found for local dot allowed. What I've added? Okay, port list. So I was accessing the wrong way. And let's see, we want instance ARN as well. Let's say instance ARN, and we will add the L value as AWS instance dot web, right? And ARN is such a name over here. Instance ARN. Okay, instance ARN is the name, I think. Right, we are done with that. Now quickly initialize our backend. Let's see if there are some errors. So it is initializing the backend, getting the provider plugins. Okay, let's just wait till then. So we have all the files in .tf. Let's see if we didn't make any mistakes. So the Terraform folder is created. Now quickly let's just do Terraform plan and see which all resources are going to be created. Let's see if we can parse all my configuration. Okay, there is something var.server.volume size inside over here, line number 28. Okay, it is server config, not server. Terraform plan. I hope we don't get any. Okay, instance ARN. This object has no argument. Okay, I think it's ARN only. Let's do this. I think it uses only the ARN. If you want instance ARN, then there are certain parameters. Yeah, that's correct. Certain parameters you want to add. See, we have multiple things. Create. We have AMI ID. We have our resources created. All the configuration passed. Right? US East 1A. Right? So in terraform.tf file, what we did, we added availability zone as US East 1A, right? Sorry, this is not the one. Somewhere around, guess, in this file, we added, yeah, this one, zone, availability zone 0, and 0th value is US East 1A, which is what it is showing over here. So let's just quickly do Terraform apply and do not wait further, because I think we have done the configuration correctly, and I'm just saying Terraform apply. Okay, I will say yes, I want to create these resources, and it is creating. Let's wait for some time. Meanwhile, I will add these files, configuration files, to the GitHub repository. You guys can take a look and try in your own way. You can create your own example. You can create your own instances. You can add multiple things. Okay, cool. So few things are there. Let me just quickly maximize the terminal, right? So these are the these are the outputs which you have got from the outputs.tf file, right? And if you want to reuse it, you can reuse it, and there are multiple ways to reuse it, right? Let's not deep dive into that. So we said we wanted the ARN, so we got that. We wanted the instance ID. Let me just open that file only. Okay, so we said instance ARN, we got that, right? We wanted allowed port list, it is over here. We wanted public IP, the public IP is here, 3.219.45.81. We will match this with our instance when we log into the console and check the EC2 instance, right? So let's just quickly check the instance as well, if it is running or not. So 3.219.45.81, right? Quickly go back to this one. Okay, cool. See, we have this. I told you this dev-web server is coming from where? It is coming from the instance name, right? Which we have defined somewhere around here, right? This is the instance name, which is then accessed by the local, and through this tag, this is getting the instance name, right? Now we check the public IP 3.219.45.81, and it's the same, right? If we will match the ARN, it will be same, and the instance ID, the last words are 3BE3C. So 3BE3C. So we got this. We got everything for security. Okay. It's we allowed some of the firewall rules. Okay, storage. We said 8 GB. So there is 8 GB, right? So this is the volume which we mounted or we created, right? So first of all, we will define our AWS region, which will be type of string, right? And then what we will do is we will provide a default value to it, which will be US East 1. And in our providers file, we will reference that using var.aws region. Okay. Now, next, what we are going to do is we are going to define environment, right? Sorry, environment, and we will say the type is string. Okay. Then next is we will have a map called instance type map, and later you will understand why I am creating this map, right? So the type is map of string, sorry, map of string, and then we will have some defaults over here. And let's say I will say that if my environment is dev, then deploy my EC2 with the configuration t3.micro, and if it is a prod, then spin up an instance which will be t3.large. Okay. Now moving ahead with the next thing, which is we have to define the subnet CIDR, okay, inside which our EC2 instance will reside. Okay, so this will be yes, I will add this string over here, and then the value I can say would be let's say 10.0.0./16. Okay, next I am going to name my server. Okay, so I will add a server names over here. The type is list of string. So here I want to use the length function to iterate through the list, and then using that I will get the number of servers which I want to create in our EC2 in our AWS account. Now last thing is we have common tags, right? And this will be type as map of string, because I want to use the merge function and give you an example over there. So we have created our variables.tf file. Next thing is we will create a shell script. So why we are doing it? So basically, if you go over here, so actually one by one I will explain all these essential built-in functions along with the conditional expression, right? And in this built-in function we have a function called file. So actually what it does, it the Terraform loads the content of the this script and it passes it to the EC2 instance, and it is useful in many use cases like for startup scripts or for configuration files or templates. So let's say for example, as soon as I spin up my EC2 instance, I want the Nginx server to be installed into it. So for that I will write a prerequisite script, shell script, and in this way I will write the installation steps over here in the shell script, and this will get executed inside the EC2 instance or while you launch the EC2 instance, right? So in the AWS console itself, you have an option where you can add a shell script. So similarly, we are doing it through the code. And first of all, what I will do is I will add the shebang over here, right? So we will have the shebang added over here. Okay, and I will say that install nginx. So this is an example only, and I will store this inside my EC2 instance. Okay, so I'm going to the home directory of my EC2 instance. I missed the E. Okay, and then I am storing this particular sentence inside a text file which will be nginx.txt. Okay, so in this way what I did, I just added this sentence into this file, and this script will be executed when I spin up my EC2 instance. Okay, so next thing is we have main configuration file. So what we'll do, we will use the power of locals so that we don't we avoid the repetition, as well as we use the derived values from the locals. Okay, so one by one let's get started with the explanation, where the conditional expression is the first example I want to take. Okay, So over here, what condition does is, let's add this in comment itself, that it is a ternary operator, right? You must have seen in the other programming languages, right? For example, in Python. So if the condition is fulfilled, so then you have two values, which is first is true and the second is false. If the condition is satisfied, it will choose the true, and if it is not, then it will choose the false, right? So let's move ahead, and let's say that my instance type will be length. My instance type I want to take is, I want to take the environment and judge that, or make a condition over here, that if my environment is passed as prod inside my variables file, then do one thing, choose t3.large configuration for my EC2 instance, and if it is used other than prod, for example dev, then do one thing, t3.micro is the configuration I want for my EC2 instance, right? So next thing we are going to learn is length function. So like I said, when I was defining the variables.tf file, so what I will do is total number of servers, okay, and I will do one thing, I will iterate through the list, right? So variables.tf, you see this is a list, right? The type is list. So what I will do, I will iterate through this list, and what it will provide, for example, in the list, if I have added 3 servers, then the value of this particular total servers variable will be 3, right? Similar to what you have seen in Python programming language. Now other is lookup function, right? So let's understand this over here. So basically what happens is, just quickly get started, look up function, right? It accepts 3 arguments, right? First is map, second is key, and then you have default. Okay, so it accepts first argument as map, right? The second would be key and the default value. So for example, I am accessing a map which have instance type, okay, and the key is, I want to identify or satisfy my requirement using the environment, and default could be like, if the environment is equals to dev, then use t3.micro. So in this way you can use the lookup function, and similarly we will just do in the same way. So I will name my variable as instance type lookup. Lookup is the function using which what I will do is, I have the instance type map in the variables folder, file, and we have variable.environment as well. Okay, so once this environment is resolved, then it will create the instance type, right? So next thing is what, we have a default value which is t3.micro. okay, so this will act as a default, and let's move ahead with the next function, which is merge function. And so far in the previous video you have understood that how it works, but still let's recollect our memory. And we have first of all, I will define a variable, let's say merged tags, inside which I will use the merge function, okay, and if you hover through it, it will basically tell you that it accepts 2 arguments or more than 2, and what it accepts in the type of maps, right? So we can merge 2 maps using the merge function. So the first is, we have defined our common tags as type map, and second is, I want to custom define my new tags, and this is also having a key value pair, so it will be perform as a map only. Okay, so this is the name dev server, and let's say quickly I will add the environment. Okay, environment as dev. Right, now moving ahead, let's talk about cider subnet function. So this is a bit tricky and important one. So this particular function is majorly used when you want to create a EC2 instance, or you want to have some cider ranges for subnet. So in this way, let me get started with this by explaining it into the whiteboard, right? Because it will take some time and it is an important topic. Okay, so we have cider subnet function. Okay, so this cider subnet function in Terraform is used to calculate a subnet address within a given IP network address prefix. Okay, so prefix is what we have defined it in variables.tf, if you remember this one. So this is the subnet cider and prefix is this one, right? So now we understood what is prefix. Okay, so this function is particularly useful when you need to create subnets from a larger network block. Okay, so like I said, if you want to create subnets from a larger network block, where you let's say example, you have a VPC of 10.0.0.0/16, right? So in this way, you will be able to understand, you will be able to get the or create the subnets from a larger network block, and this function accepts IPv6 and IPv4, both of the network prefixes, right? So basically it also accepts three args, right? So first is prefix, and we know what it is. The next is new bits, and then net num. Okay, now understand this. Prefix is already clear. We have 10.0.0/16 in our example, and new bits is when you want to add the number of additional bits to extend your prefix, this one. If you want to extend this, so in this case you will add 8. Let's say if you want to add 8, then this 8 will be added to this. Okay, and it will become 10.0.0./24. Now let's understand what is net num. So this is basically whole number. This is what whole number that represents the subnet number within the new bits, within this new bits, and this number is used to populate the additional bits added to the prefix. So this is the prefix. Now you know it. So let's say if I have the prefix of this range, then this means that the IP range of this prefix will be 10.0.0.0 to 10.0.0 and 255. So over here you have 2 to the power 16 addresses. Okay, now similarly, if you, and in this case, if you add the new bits, let's say if you want to extend your bit with the 8 bits, extend your prefix with the 8 bits, sorry, then in that case what will be done? Then 16 plus 8 is 24. Now your new prefix becomes /24, and the number of subnet depends on new bits. So now the additional bits which you have added, which is 8, now you have 2 to the power 8 subnets present to add into your EC2 configuration. Okay, so now you have understood what is new bits, and in total you will have 0 to 255 subnets, right? 2 to the power 8 is nearly 256. Okay, and each subnet will contain 256 IP addresses. So this is a part where you will need to basically brush up your skill on networking so that you can understand this concept. So now when you have this 255 subnet, then you can have Let's take example in this way. Okay. Similarly, it will extend to subnet 255. And let's say the first subnet is 10.0.0.0/24. The second will be 10.0.0.0. Sorry, this will be 1 over here. Okay, 24, and so on and so forth, right? So the function cider subnet, what you will do, first of all, you will pass your prefix here. Then next is you will pass the number of bits, new bits you want to extend to your prefix. Then the subnet which you want to use. For example, if I've added 1 over here, and in that case, this is the subnet which will be used. Now you've understood what is cider subnet function. So let's just quickly go into our code and understand this. So we have a cider subnet function which we are going to use, and now you've understood very well, right? So let's define our variable in this way. Let's say subnet 1. Okay, and I'm going to use cider subnet function, and first thing I will do is I will add the subnet cider which I have used in my variables.tf file. Okay, next thing is I want to extend it with 8, and I want to use the first subnet. Right now we'll move ahead with using the for expression in list and map. Right, we have these two things present over here. Okay, so what I will do is I will define this variable instance server names and get the name of my servers. Okay, so I will use the for loop and name in var dot server names, right? Similarly, you use in Python, same way you'll use over here. It's added 2 times. Okay, var dot server names, and what I will do is I will just convert my server name with uppercase, so that to standardize the process, if someone is using a lowercase or someone is using a uppercase or a mixture of it, then in that case the server name will be converted into the uppercase character. Okay, and I will say name. Right now we are going to use instance instance tag. Okay, now what we will do is we are going to iterate through the map, and this way you can iterate through the map in the var dot common tags. Right, so I'm iterating through this map to get the tags, right? And similarly I will do one thing, I will add the upper key over here so that it is converted into upper, and then what we will do is we will store it. We will get the upper value, so the key value pair we will fetch it, and which will be this one. Right, now you get all your values, everything. Now let's do one thing quickly, just launch our or write the configuration for our instance. I will say AWS instance. Okay, like in previous example, let's take the name as web. Right, the first thing is AMI. Okay, and AMI, from where we can get it? We can get it through this dashboard. Okay, so it will take some time to load. Let's wait, and let's see if we can get this. Yeah, we got this one. This is the AMI ID which I want to use. Now moving ahead, I think I missed to copy A, and then we are good to go. Okay, now what I will do, From my locals block, I will take the instance type because we have defined it before, right? So I'm going to reuse and this instance type over here, right? And for count, like how many instances I want. So we have total servers over here, right? And this will be fetched. So what I will do to the local block, I will say, give me the total servers, right? Now you understood this. So next thing is, I want to use this particular script when I deploy my instance, right? So I will name a variable called user data and I will use the file function, right? And this is the important thing where if your scripts are present where your main configuration file is present, then you can directly use the name of your script, or if it is present elsewhere, then what you can do is you can use the relative path. Okay, for tags, now we know that what we do, we use the merge tags, right? Somewhere around here we define this one, right? So in this way, what we have done is we have understood each and every topics over here. We use the conditional expression for environment based logic, we use the length, we use the lookup which accepts 3 arguments, then merge, which basically merge 2 maps, more than that. Then we have file, right? So that we can pass the configuration script, and then we have CIDR subnet, which we have understood in detail, right? Then we have for expressions where we transform the lists and maps. And now let's create the Terraform TF wars file where whatever the configuration we have done in variables, we will pass it from here. So let's say environment is dev, because obviously if I do it prod, then what it will do, it will launch EC2 instance of t3.large and I will get build heavily, right? Next thing is server names, right? Yeah, over here somewhere around, yeah, server names. So for this example, I'm going to take 2 servers. Let's say API server, and next is web server, right? So this is a list which have 2 values, and if we take out the length of this list, so what it will be, 2, okay, using the length function. Then we have common tags. Now let's quickly populate this. Let's say I want to tag the project and say that this is Terraform practical project, and let's say owner is me. See, these metadatas are very important when you work in at enterprise level or in any IT company, because through this your resource is identified. That is why it is very important to add tags. And next is, I want to say that, okay, I've already, I think, defined it in the main configuration. Let's see, yeah, this one. So it's not required anymore. And let's do one thing quickly, initialize the backend. Okay, so we are under lecture 4, and what it says, command not found. Okay, I missed the R. Now it will take some time to initialize the backend. It will install the provider plugins, and then it will save the binaries, provider binaries, then log the file, the hashes, everything. So let's wait and see if we didn't make any mistake. I think we did not. Let's move ahead and let's say Terraform plan. So you see the log file is there, the tf state log file is there. Okay, now over here you will see that your resource is going to be created, your AMI ID, your instance type, your region, your tags, and everything, right? Over here you can see that it is saying that this particular script will be launched or run at the time of your instance launch. Okay, and see, this is AWS instance.web1 and this is for AWS instance.web0, because we have added over here, if you see the count as local.total server. So total servers, how many we have? We have 2 servers, which is API server and web server. So it is referencing it in this way and it will launch 2 servers. So all the configurations are there, and here you see that 2 to add, which means 2 resources will be added, 0 will be changed and 0 will be destroyed. Now I will just quickly apply the changes, wait and see. Okay, I will enter yes, and let's just wait. Or what we can do is we can just directly go into the console, refresh this page, come over here, refresh this page, refresh this one. Let's see the status inside our code. Okay, it says apply complete resources, 2 added, 0 changed and 0 destroyed. Now we have 2 IDs with AFDD and 4195, right? Ending with AFDD, this one, and 4195, right? Inside this, if you go and check the tags, these were the tags which we defined, isn't it? And by default the storage is 8 and everything looks good. You have a public IP address and that's it. In previous lecture, we understood some built-in functions, right? But you must be thinking that, Rahul, you defined the lookup function, the CIDR subnet function, the for expression in list and map for instance server names and instance tag, but you have never used it, right? Inside my main block, I've never used it. So I kept all of these functionalities untouched intentionally because I'm going to extend this particular example into my today's lecture. So first of all, what I will do, I will copy all of these files into my lecture 5, right? And then let's extend this particular example. Okay. So first of all, for the instance type, I have used local.instance type, which is what? It is derived from the conditional expression. So we could have used in either way, either for lookup function or for conditional expression. So for the first example, I've used the conditional expression, and for today, we are going to use the lookup function. So instead of adding the instance type over here, I will add instance type lookup. So it will similarly do the same work and create my instance. Now let's move ahead and see what else is left. So CIDR subnet function is the one which we have talked a lot about in our previous lecture. So let's extend this as well. What to use the CIDR subnet function? First of all, we need to create the VPC, and we have defined our prefix over here, right? So with this IP address, I want to create a VPC, and inside this I want to create the subnet so that I can use the CIDR subnet function, right? So first thing, I will define the VPC and I will say AWS VPC, right? The name, I can keep it as main, okay? And I will add the CIDR block, and you know very well that we will extend it from our variables.tf, and we have var.subnet CIDR, right? Then for tags, let's say I am going to merge, okay? I'm going to merge the local.instance tag, right? And then after that, what I can do is I want to add some more tags over here. So I will name my VPC, let's say main VPC, and I will name the environment, okay, and say it is for dev environment. Now we have our AWS VPC, right? So let's add a comment over here and say it is a VPC. Next thing is our VPC is defined. Now we want a subnet, right? Similarly, I'll just create a resource of AWS subnet, and the autocomplete will help me. And I will say that this is a public subnet. Why we need public subnet? Because we want to connect to our instance, right? So for that, we need a public subnet. Okay, so what is the issue? Okay, let's define the attribute. It is saying define the attributes, right? So first of all, what I will do is I will reference this particular AWS VPC into my subnet and launch our subnet into this VPC. And we know how to reference this. And in our second lecture, we have understood how to use resource type address, right? If you haven't seen that, go and watch that video. Now I will do this. I will take the main and take the ID. Now my subnet is associated with my VPC, correct? Now for the CIDR block, what I'm going to do is I'm going to use this subnet one, which have the CIDR subnet. And if you remember in our previous lecture, what we understood, the derived value for this was 10.0.1.0/24, right? So this value will be populated over here. Okay, so I will say local.subnet1, and for tags, let's again use the merge function and say that local.instance tag I want to use. Along with it, I want to give the name of my subnet as public subnet. Clear? Now we have used the CIDR subnet function. We have created the VPC. The subnet is associated with that VPC. Now let's move ahead and see what we can do in this particular block where we are adding the configuration for our EC2 instance, right? So for count, you already know we have used it, and it says local.total servers, right? And it is derived from here. So basically what it is doing is it is iterating through the list which we have defined for the server names, and it is creating two servers, isn't it? So there is a problem with count, and let's understand it very clearly, because in production or in the mainstream applications, we don't use count more often because there is some limitation to it. And let's understand what is the limitation. We have this list, right, defined in our TA wars file, and you know that inside this, these are the server names which I wanted, with which my EC2 instance should be created: API server and web server, right? So we were understanding the problem with count. So when we used count, basically it converted my instance into this format, which is the AWS instance.web count 0 is API server and web count 1 is web server, right? In the previous lecture, in the console, you have saw that the 0 was the API server and 1 was the web server. So the problem with count is if you change API server, this list, to, let's say, web server only, right? So what will happen? Terraform will do destroy this API server, it will destroy this one, and then it will recreate the web server. So this basically is called index shifting problem, right? So what is index shifting? So when you use count, Terraform identifies resource by numeric index, which is 0, 1, in this way, right? So if you, let's say, define 3 server names, then it will identify the resources through this index, right? And if the order of your list changes, Terraform reassigns indexes, which can lead to unnecessary destroy plus recreate of resources. Now when you change the list, like I said, it will destroy this one API server and it will recreate the web server. So how Terraform sees this, it is like, let's say API server is for this 0 index and web server is for 1, right? Let's just remove this one, and let's say the first time you applied with the help of count, then these were the resources which have been created, and it can be considered old state, right? So when you change the list, what it will do is the new state is, it will say that, okay, now I only see one index, which is 0, and I will only create web server, which will result to recreating this web server which was already created and destroying of API server. Even though if I wanted the API server to be unchanged, right, or not to be destroyed, right? So this was the problem, and this problem is like basically solved by for each. And let's understand one more thing, that Terraform, if you use count, then Terraform identifies the resources using the index. It will see that, okay, if this particular index is there, it is a resource, right? And not like this, the name, okay? Not like this. So here we just changed this one, we removed this one, and the name was same. Even though the name was same, the Terraform will do recreation of this particular instance, and then it will destroy the API server. So when index says shift, Terraform thinks this is a completely different resource, and it creates this, right? So the problems over here, like I said, in real world application or mainstream applications, or even in production environment, this can cause downtime, the data loss, service disruption, and also it can have unexpected infrastructure changes. Okay, so what is the remedy for it? Instead of index based tracking, what we can do is we can use key based tracking, okay, which is provided by for each, right? So which is provided by for each. So in this example, you see, instead of indexing it, what for each does, it will say for each API server and for each web server, right? So through the example, let's quickly understand this. So inside my main block, let's remove this one. Inside my main block, what I will say is for each to set, right? And I will say var dot server names. So what it will do, it will do key based tracking instead of index based tracking. And then I will just add a comment over here. Okay, I will say that for each expands resources, right? And this particular lookup is evaluated through this for each. Okay, I will write lookup is evaluated by for each. Okay, and even though this lookup returns a single value, right? It returns a single value from here, right? Which is when we pass var.environment as dev, a single value will be passed, and it will say that, okay, you want to spin up a dev instance, right? So then in that case, even though lookup returns a single value, that value is applied to each instance created by for each. Okay, rest I will keep the same, and for tags I will change it. What I will do is I will do a merge of local dot merge tags. Remember, we defined it, and what we will do is I want to add a name, but what we'll do, we will use each dot value, right? In this way, whatever the value will be here. So for example, the first is API server and the second is web server. This will be passed over here, and it will create two instances with different names, correct? So what Terraform will create, it will create AWS instance dot web for each API server, and similarly for web server. So why for each is better? So even if you remove the API server, only API server is destroyed, web server remains unchanged, correct? Now moving ahead, let's understand dynamic blocks. Okay, so I have already kept this example ready. So let's understand the dynamic blocks. Now when you use dynamic blocks, it use the nested blocks repetition, right? And where it can be helpful in our example, it can be helpful in security groups. So let's make a visualization chart over here with which like we can see that how this works, right? The dynamic blocks. So let's say I will take an example of security groups. Okay. And let's say the allowed ports for the security groups is 22 for SSH, 80 for HTTP, and 443 for HTTPS. So what it will do is the dynamic block will loop through this, and it will create the security group with the ingress value of, just a minute, with the ingress value of 22, the next time it's 80, the next time 443. Similarly, you see over here, first it will create this ingress, then second, then third. So this can be helped when we want to use the repetition or we want to loop through for a particular use case. Let's take the example of dynamic block. So for that, I will create a resource, okay, security group, and the name of my resource will be web_sg, and the security group name will be web-sg. Okay, now let's create the dynamic block and say ingress, right? So I will do one thing. I will create a for each block, and I want to use some of the ports, right? In our example, you see we used 22, 80, and 443. So let's do one thing. First, go to variables.tf, create a variable called allowed ports, okay, and the type would be list of number, right? Now in the next step, inside tf wars file, I will define this, okay. So the first is 22, and we want 80, and we want 443, correct? Now next thing is let's use the allowed ports over here, and what it will do is we want to define a content as well. So basically this content will loop through this particular value, whichever will be present over here. So for example, var.allowed ports are 3, so it will loop through these 3 values, and it will populate those values into our security group. Now inside the content, let's see what we can add. So from port, we want ingress value, okay, and to port. So these are some of the configurations of security group, right? Now let's add a protocol, which is basically TCP I want to add, and let's say the CIDR block from where I want the traffic to flow, I just keep it to all. So basically 0.0.0 means the traffic will flow from all the internet. Okay, now the security group is done. Okay, so next thing is what we want to do is we want to reference this particular security group inside our resource instance. Okay, so let's do one thing. So first of all, for instance type, we are using local.instance type lookup, okay, and we are using for each, right? So when we are using for each, we want to comment this out, right? Count, because at that time it will throw error, and the Terraform will say that you have defined count and for each, both of them, in which way you want me to create the EC2 instance. Okay, so let's reference the security group, and it is referenced through the security group IDs. Okay, quickly I will add the security group web.sg.id. One more thing we are missing is we haven't defined the subnet inside which we want our EC2 instance to be present. Okay, so we have created this subnet over here, right? And we will reference it in this EC2 instance and associate it. So let's say subnet id, and I will do dot public subnet dot id. Cool. So we cannot directly attach the VPC to our EC2 instance. So what we can do is we will attach the subnet ID, okay, the public subnet, and which in return is associated with AWS VPC. Now let's do one more thing. So we will attach this security group to our VPC, okay, because if we do not attach it, then what will happen? This particular security group will be created inside a default VPC, and we have created our custom VPC. So in that case, first the subnet is associated, then security group is associated, and then my EC2 instance is associated with the subnet so that it can reside into this particular VPC. Correct? Now quickly initialize the backend. Okay, it will take some time. The backend is initialized. Let's do a Terraform plan now, and it will show me, yeah, so these many resources are going to be created. And in our previous lecture we saw that there was .web0 as the API server, and it was doing index based tracking. So now what it does key based tracking with the key as API server, and the next key is web server, right? And all of the information you can check over here, you can go through it. Now let's quickly do Terraform apply. Let's wait for some time. I will say yes, and let's see if we have done things correctly or not. And it is creating the VPC, right? The creation is completed. Subnet, it is created, the security group is created, and now it is creating the EC2 instance and associating it with the subnet, the security group which we defined inside that particular VPC which we defined over here, right? Now let's wait and see if the resources are created. Okay, so 5 resources added, 0 changed, and 0 destroyed. Now quickly we will go into our console and check. Okay, I will refresh this, and let's see if the instances are there or not. Yeah, it is there with the name API server and web server. Now let's match the ID 54F4 and 1230. Okay, so we can see 1230 and 54F4, right? And I will take example of one of the instance. I will check this. Okay, so this was the name of our VPC, if you remember, main VPC. I will open this one, right? And yeah, this is the name. And let's see what else is there. Okay, these are the tags which we created, isn't it? Now next thing is we want to check the security. So these were the security port range which we defined into our dynamic block. Yeah, and these were the allowed ports, right? The security group name was WebSG, if you remember. If you go over here and see inside security group, yeah, this is the name WebSG. Similarly, it is present over here, WebSG. Okay, and this security group, let's see where it points it out. Yeah, this is the one. Okay, and for subnets, let's do one thing. Go to VPC and let's see. Okay, so this was the prefix which we used, right? If you remember. And then for subnets, let's go over here and check. See, so 2 subnets have been created because we had 2 EC2 instances, and each one is attached to one of the EC2 instance. Now let's click this one. Okay, so it says it has available IP4 addresses 251, right? But in our previous lecture, I have said that it has 256 value addresses, IP addresses into a particular subnet, but it has only 251 over here. Why? Because 5 of the IP addresses are reserved by AWS itself. That is why we can see 251 IP addresses are there. And see, I told you 10.0.1.0/24 will be used into this particular subnet. This is the IP address which will be used, and particularly this is the one which has been used, right? So If you have some doubts, you can see the previous lecture, you can rewatch it, and the same way, like I said, this IPv4 address will be used. It has been used. We can see 251 IPv4 addresses available over here, and this is associated with my EC2 instance, right? You can see the tags are also there. Now, let me ask you a question. Where does Terraform remember what it has already created? And also, what happens if two engineers run Terraform at the same time? So the answer is, we handle these situations or these things through Terraform state. In lecture 2, I have already explained Terraform state and terraform.tfstate.backup. Please go and watch that video first. Today, let's concentrate onto the issue with Terraform state stored in local and what is remote state and backend configuration. Okay, so Terraform stores infrastructure details in a file named terraform.tfstate, right? So it has your resource IDs like VPC ID or EC2 ID, right? It has metadata, okay? It also has some dependencies within your resources and the outputs you have produced, right? So understand it in this way that Terraform state is the single source of truth for your infrastructure. Now let's understand the Terraform workflow diagram. So I've created a workflow diagram over here. So let's say an infra engineer or a DevOps engineer writes the Terraform code. Then Terraform reads current state and it compares with desired state, generates the execution plan and updates state after apply, right? You can see the Terraform core is actually reading the state file and it reads all the configuration you have mentioned into your Terraform code, right? After all the provider plugins and provisioners, etc., what it does, it apply your changes and your infra is created in any of these clouds, right? So Terraform doesn't guess, it compares desired versus current state. Now, till now, what we were doing, if you see, we were storing our terraform.tf state in local, right? And there's a huge issue with that. So let's explain, let's understand that. So if the Terraform state is stored locally, you may want to share these Terraform state files or your configuration to someone. In that case, what would happen? You will share it over mails or chats or any other communication method, but this is not secure because you may have some secrets embedded into it. So in that case, what will happen? Your secrets can get leaked or compromised. Okay, it is not safe for teams, and we will understand this later how. Okay, and if you store your Terraform state, then you have no locking mechanism. Okay, second was not safe for teams, and first we understood that sharing is not acceptable because your secrets can be compromised. Okay, your Terraform state can be corrupted, it can get corrupted, okay, and secrets may store in plain text. Okay, so these are the limitations which you see if you store your Terraform state file into your local machine. Okay, so what is the solution for it? The solution is remote state. And in remote state, what you can do, you can store your state either in any of the storage or in any of the cloud provider. Either it is AWS S3, Azure storage, or else Terraform cloud. Right? Now we are going to take the example of AWS S3 only. Okay, and first let's understand what are the benefits to store your Terraform state file into your remote backend. Okay, now let's understand what are the benefits. So we have a centralized state. Okay, now your team can collaborate, and you have state locking, okay, and versioning as well. You can version your state file, right? So versioning will help you to understand what was the previous state of your infrastructure, and in this way, if something goes wrong, you can come back and you can apply the previous versions so that your infra is up and running all the time. And also you have a option of secure storage, where your Terraform state file will be secured, not get corrupted, encrypted as well. So we will understand how to configure backend when we will write our example code. For now, just understand that backend configuration tells Terraform where to store and manage the state. Everyone says that configure remote state backend and create a lock using DynamoDB, but no one explains why should we do that, right? So let's understand why. So for that, first let's understand the concept of state locking. So state locking prevents multiple users from modifying state simultaneously. So let's say, imagine me, let's take an example, okay? Imagine me and my teammate Rohan both are working on the same infra repository, right? So here I am, okay, and here is Rohan, right? So we both are working on the same infra repository, infra repo, right? And I am updating, what I am doing, I am updating my instance from t3.medium to t3.large, okay, in the production. And what Rohan is doing, Rohan is adding S3 bucket to the same project, the infra repo, okay. So we both type, what we did, we both type Terraform apply and hit enter at the same exact time. It can happen, right? It's a coincidence, but it can happen that we both have applied the configuration at the same time. So let's understand. This is me, okay, and I have read the state file, let's say version 1, okay, and S3 bucket has our backend, state file, shared state file, which is shared across the team, okay. So if it is shared with me, then it is shared with Rohan as well. And what happens, it also, Rohan also reads the state v1, the version 1. So now what will happen, so what I did, I actually deployed the web server with the upgradation of t3.medium to t3.large, and I have written the state, and the state is now version 2, from version 1 to version 2, and it contains what, web server, it contains web server with higher configuration. And now Rohan was also doing the same work, he was also working on the same repository, but he was adding S3 bucket rather than the upgradation of the your instance, right? So he deployed the S3 bucket, okay, and he wrote the state, which now became version 3, right? And what it has S3 bucket, okay. So now what it will happen, that he had the same version as me, v1 and v1, but when I applied the changes, it became v2, right? But Rohan had the v1 version, where the web server upgradation was not there, right? The web server upgradation was not there because I was working on it and I didn't created the state, or I haven't created the v2 version of it. So what happened, Rohan applied the changes and it overwritten, like it overwrites my server update, right? I updated the server, but the next time Rohan made any apply or made any changes, it became v3 and it overwrites my server update, right? So what happened? The state gets corrupted, right? Because Rohan's Terraform process didn't know about my changes. It read the state before my changes were written, and final write overwrites my state, right? And also the issue. So first is what issue we faced? We faced state corruption issue. Then what happened? Orphaned resources. What does this mean? What does this mean? Basically means the cloud provider successfully upgraded my web server, but because Rohan state file overwrote mine, so Terraform has now forgotten about my web server upgrade. Okay, and also I have duplicate billing. Why? Because the next time Terraform runs, it will see the state doesn't match the code and might try to spin up another web server, right? So I made the changes and I pushed it to the repository, and when Rowan made the changes, the version was v3. The next time what will happen if someone goes and apply the changes, now v4 version will be there, but with the upgradation, right? So there will be two server, the v1 version which resides in the v3. So v3 has what? v3 has t3 dot medium web server, but I made the changes to the repository and I pushed it. So what will happen? And the repository push have the t3 dot large version. So what Terraform will think that okay, the user wants to create a web server with t3 dot medium as well as t3 dot large. Okay, so it will spin up two instances and we will have the issue of duplicate billing. Got it? So I think this is clear for now. Now let's understand what is the solution. The solution. Okay. So state locking acts as a mutually exclusive flag. What does that mean? Which means that do not disturb sign is put on your state file. This is your state file. Okay. When you state your lock, then it gets a do not disturb sign onto it. And how it works, let's understand this. Let's say I have made the changes and applied the changes. Okay. Now what Terraform will do, it will check for lock. Okay, so we are discussing over here that why locking mechanism is very important, so that we can collaborate with our teams, right? It checked for the lock, and what it did, what it did, it grabbed the lock. Okay, it grabbed the lock which has a flag in DynamoDB. Okay, so basically we make a table in DynamoDB and we put a lock to our resource which is the state file. Okay, so what happened? I made the changes. Okay, I've used the Terraform apply command. So Terraform will check for the log. It will grab the log, and the log will have a flag in DynamoDB. Okay, and later we'll understand what this flag is as well. Okay, so next time what happened? At the same time, Rohan was also doing the same thing. He said, I will also apply my changes and I will also create a S3 bucket. Now what Terraform did? It again checked for the lock, and this time what happened? Rohan got an error that your state is locked. State is locked. Okay, because I was using it and the lock was already present over there, which is why Rohan got the information through the terminal, the Terraform through an error that the state is locked by Rahul. State is locked by Rahul, and try again later. Once I am done with all the process, I will release the lock, and when the lock is released, then only Rohan will be able to apply his changes. Right? So you understood. First thing what happened? Okay, just a minute. First thing what happened? We created a lock in DynamoDB. Okay, DynamoDB. DB, and I was going and making a change. Okay, and it checked the log, Terraform checked the log, grabs the flag ID and logged my state file, right? Next time when Rohan was trying to apply the changes, it saw that the lock is already there, so uh, he will face a error. Okay, so what will happen then? Here I am and I will deploy a web server. I'll be able to deploy a web server now. I will write this into my state and the v1 version will become v2. Now I will release the lock. Once the changes are made, the lock is released, and then what will happen? Rohan will apply the changes again. He will apply the changes again and he will check for the log. Okay, and he will grab the log, which is the flag ID, and it reads the v2 version now. Which version? It will read the v2 version now. Let me add this. It will read the v2 version now, and then the changes will be applied to v2 version, not v1. Okay, so in this way we are safe now. The web server is also upgraded, and the S3 bucket which Rohan wants to create it is also there, and we don't have any state corruption or we don't have any drift in our Terraform state file. And in this way we saved ourselves with duplicate billing, right? You saw this, and we saved ourselves from orphan resources and state corruption. Okay, so let's move ahead and let's understand this through an example. Okay, so we will take an example of AWS only because we are working on AWS as of now. So by default, AWS S3 bucket where we store the remote state does not log files. Okay, so when we want to store our state file, so what we do, we find a storage account and we store it. So in AWS we store in S3. Okay, but by default what happens, it does not have a mechanism of locking your state file, isn't it? It does not have that. Okay, it has your server side encryption, it has to disable your public access, it has the capability of versioning, but it does not have the locking ability, right? So which is why we pair S3 with DynamoDB so that we can pair the mechanism of storage plus locking, right? So what happens in DynamoDB? In DynamoDB, okay, we create a DynamoDB table with a primary key as lock ID, right? This is primary key, and we created a DynamoDB table with primary key as lock ID. And when we run Terraform apply, Terraform creates a row. It creates a row. So it is just like a database, DynamoDB, right? And it creates a row inside that table, and it has what it has: your computer's IP, okay, your username, and a timestamp. So this value will be stored in DynamoDB, and this is a flag, right? We were talking about the flag over here, this one. So this is a flag which is stored in DynamoDB, right? While that row exists, no one else can run Terraform apply. Okay, so if this row exists in my DynamoDB, then no one will be able to run the Terraform apply command. Whenever my apply finishes, then only Terraform automatically deletes this row, right, from DynamoDB, which will free up the lock for the next person. So what happened? say Rahul made any changes and he ran Terraform apply. So what will happen? Terraform, sorry, what will happen is our state will be stored in the form of IP, username and timestamp, and it will create a row in DynamoDB table. Until my changes are applied and finished, till then this row will be appearing in DynamoDB. Once the changes are applied, then what will happen? Terraform deletes this row, which means your state is not logged anymore, and now anyone else can make their changes and apply and create infrastructure. Okay, so there's a very there's a example which you can also see a caveat to it. Okay, so think of it in this way: what happens if your laptop dies or your internet drops right in the middle of a deployment? So the lock will get stuck in DynamoDB, right? So let's say you are making any changes and you did Terraform apply, and at the same time the power is gone, or maybe your internet is down, or maybe your laptop gets automatically updated or something like that. In that case, you will be stuck, right? The lock will be there, the lock will be present in the DynamoDB table, and if someone else wants to apply or make any changes, then what will happen? He or she will not be able to make any changes. Then what is the solution for this? There must be a solution, right? Because there can be some cases like this which has happened before, and which is why we have a caveat to it. So if this happens, you have to use a special command which is called Terraform force unlock. Okay, and the lock ID. From where you can get this lock ID? From DynamoDB. Clear? Now you understood? Okay, let's again go to the Terraform workflow diagram with the remote backend, and this is also what I've created. So let's understand it in this way. Okay, so this is what I will commit to the repository. You can take a look over this workflow diagram and understand it, and if then also you will not be able to understand, then you can rewatch the video again and again, because this is a very important concept, and this concept is coming into interviews again and again, and every IT company asks this in their interviews, that how you manage your state, what is the concept of lock-in, and what is the remote state backend configuration, how you do that, how you prevent multiple developers working onto the same state file. So these kind of questions will definitely come into the interviews, which is why this example is very, very important, and you should like learn it by heart, right? So let's understand this workflow. So let's say this developer has created a Terraform configuration file, and it like he uses the Terraform commands, and it is somewhat also automated through a CI/CD tool, but let's not understand this. Let's ignore this part as of now. The developer made any changes, and he wrote the configuration file, then he'll apply the Terraform commands. So the first step, what will happen? Okay, first step is you need to apply the commands, right? The second step is it will acquire the log into your DynamoDB table, and you can see over here, this is the log ID, and this is the example over here. So something like log abc123. Okay, so as soon as you hit your command, then you acquire a log in DynamoDB table, right? The next step, what happens? Your Terraform reads the state file. Okay, and if there are some IAM policies to restrict access to your S3 bucket, okay, or it will check that if the bucket is encrypted or not, if it is version or not, right? So this is also a classic example, and it is used in many of the IT companies, where it can be considered as a production based architecture, where we restrict the access of some particular users, and we provide access to only those users who are trustworthy. Okay, so how do we do that? We apply IAM policies to restrict access to the S3 bucket. Okay,
So this is the third step where we read the state file. Now, what is the fourth step? Once the state file is there, it will compare your current state versus the desired state, and it will provision or update your resources according to what you have written in the configuration file. Okay. Now, what will happen? Uh, the fifth step is, once you do all of these things, right, then you have your new state file. Okay. So it will update the state file into your S3 bucket, and then sixth step is, once the updation is done into your S3 bucket, sixth step is it will release the lock, and now the next person can the next person can apply the changes, make any changes, or add or delete, or update something, and he will also follow the same mechanism. Okay, so over here you can see locking prevents the conflicts and race conditions. Race conditions means if someone is alongside, like I've given the example that 2 or 3 people are working at the same time and they are doing the Terraform apply command, then this can be considered as a race condition. Okay, and when multiple users try to run the same configuration. So now we clearly understood what is the issue with storing your state file into local, what is remote state, and what is backend configuration, how we use, how we combine the storage plus locking mechanism, and what is the concept of locking, right? You saw this example. You can rewatch this again and again and understand it by heart, because like I said, it can be very useful, and it can be asked multiple times in your interviews. Okay, so let's move ahead and implement this using an example code. Okay, so in my lecture 7 only, what I will do, first of all, I will create a directory, right? I will create a directory called backend. Why? Because I want to create the S3 plus DynamoDB combination. See, what will happen is, Terraform backend is initialized before resources are created. So let's say if you if you store your backend, I mean the S3 and DynamoDB in the same configuration file as of what you have for the other resources, then when at the time of Terraform initialization, what it will the Terraform what it will try to do, it will check that your backend you have given some configuration, but your S3 and DynamoDB does not exist. So for that, what you should do, first of all, you should create your backend, and then only move on to your project, do changes, create any resources, instances, S3 bucket, anything, and then that will be actually version managed or logged using this particular backend. Okay, so quickly I'll just create a configuration file, right? And for provider, let's go with basic syntax. I don't want anything flashy over here, right? So let's say I want this into my region US East 1. Now next step is I need to create the S3 as well as DynamoDB, right? So let's quickly create AWS S3 bucket. S3 bucket I have, and let's name it state bucket. So the resource name is state bucket, and the bucket name will be, which you will see over AWS console, I will say Terraform practical 6. I have to keep this unique, because if the name is taken, then again I will face the issue at the time of applying my changes, right? State bucket. Cool. Okay, again it has to be bucket, not name, right? So we have the name of our resource as state bucket. We have bucket called Terraform practical 6 state bucket. Okay, next thing what we will do is, so like in our earlier update, what used to happen is, you can combine all the configuration in the same resource, like in the AWS 3 bucket. So for example, I want to do encryption, or I want to do the versioning, I want to enable the versioning. Then in that case, earlier what used to happen is, we can combine all this configuration into the same resource, but now in the newer versions, it has removed, and you have to basically what you have to do, you have to separately define your resources. So for example, resources as in, if I want to connect this or I want to encrypt this S3 bucket, then what I will do is I have to create a separate resource called AWS S3. Let's see over here. Okay, S3 bucket server side encryption configuration. Okay, so now in new updates, what happens is you have to create a separate resource and you have to reference this particular resource into this particular resource using the resource type address or dot notation. And in this way, what will happen? This server side encryption will be attached to your state bucket. Okay, let's name it encryption, or the short form is ENC. Now, like I said, what you have to do using the resource type address or dot notation, I have to reference this particular bucket into my server side encryption. Okay, cool. Now let's add a rule, because in the encryption we have to add a rule, and I will say apply server side encryption by default. Okay, and what is the algorithm with which you want to encrypt your S3 bucket? It is AES 256. So you don't need to learn all of these. You can go to the Terraform registry and find all this information. I have done it again and again. That is why like I have this in my mind, so that is why I'm using this. Okay, now what we have encryption. Next step is we will create versioning, right? Because versioning is very important for your state to understand that what was your old state and your new state and what changes have been made in your new state, right? So which is why we will again use S3 bucket versioning, right? And simply I will just name it, the resource name, as versioning. Again, let's reference my S3 bucket and it's there. Okay, I missed ID over here and here as well, because I want to identify my resources through the ID. Okay, now what he is saying, there is a issue, there is an error, you can see over here, and what he is saying that you have to provide the versioning configuration. Okay, so there it is. I am saying status is enable the versioning. Cool. Now next thing is you want to secure S3 bucket as well, because if your S3 bucket is not secure, then in return what will happen? Anyone can access your Terraform state file, right? So you don't want to do that. Okay, so for that what you can do, you can block the public access. Okay, this is the one, I guess, account public access block, and let's name this resource as block, and I will say that reference is my S3 bucket, S3 bucket dot, what it is, state bucket dot id, right? Now the next configuration which I want to pass is block the public ACLs, and I will say true. Okay, also block public policy, and I will say true. Okay, and let's say ignore public ACLs, this is also true. And again, I will restrict the public buckets to access my bucket, so that any of the public bucket cannot make a API call to my bucket, right? And I will say true. Now S3 configuration is done. Let's see what's the issue. Okay, an attribute named bucket is not expected here. Okay, I understood the issue, I guess. So over here it's not account, actually it's S3 public access block, I guess. So basically that resource is used at account level, and this particular resource is used at S3 level. So once again, I will, for my safety, what I can do is I will say S3 account, not this one, right? What I will do is AWS S3 bucket public. Okay, come on, it's, yeah, this one. So I was waiting for the auto completion to be done, and in the hurry what I did, I used account over here. So like I said, this resource will be applicable to account level, not the resource level, and right now we are not doing it. We are just creating a resource, and we want to add this configuration at the bucket level. Okay, which is why there was an issue. Now you see the error has been removed. Let's quickly create the DynamoDB resource dynamo. Okay, not in this way. DynamoDB table. Okay, and I will name it log table. Why? Because it is storing our log. Okay, now let's see name of the table. Okay, so the name of the table would be Terraform log table, right? No issues. And I will say billing mode to be added, and it should be pay as per request, something like that, or pay per request. I don't know. Let's just go over here and see billing mode in DynamoDB using Terraform. So I don't remember exact thing. Okay, let's use the AI instead. It says pay per request. Yeah, cool. I'll just copy this one and let's add this configuration over here. Okay, and it's done. Now I will create a hash key which is log ID. Okay, and I will attribute I will add an attribute, right? And I will say that name of that attribute is log ID, and the type will be of string. So in this way you create a DynamoDB table and you pass the minimal configuration. There are n number of configuration, but for now we need only these many, right? Now let's do one thing. Go to our okay. I think I have created this outside backend. Let's move this. Now let's go to backend and quickly initialize the Terraform. Meanwhile, what we can do, we can create a main.tf configuration over here so that we can define our we can define our backend configuration. Okay, so I will add provider AWS. Okay, and region is US East 1. Cool. Now we have for defining your backend, what you need to do is you have to create a Terraform block, and inside that you want to state what type of backend you are using. Either it is a Azure storage account or a S3. So it will understand it is a S3 because we have provided the provider over here, and we are also saying that S3 is the backend where I am storing my state file. Okay, I will use the bucket name from my backend, which is, let's see what I kept the name. Okay, this is the one, right? I will add this over here, and this is the bucket where I am storing my state. So I am adding this configuration in the backend, and I will say the key is terraform dot tf state. Okay, so this is the key I want to store in my bucket. Okay, and it will be present over here only when I will initialize my backend in the lecture 7 folder. Now let's do one thing, define the region as well, US East 1, and also configure the DynamoDB table in our backend, and the name is Terraform log table, right? This is the name of the DynamoDB table which will be getting created into the AWS account. Okay, now I think it's done. Let's just quickly do one more thing, Terraform plan. Let's see what all resources are going to be created. Hope we haven't made any mistake. Okay, it's fine, right? 5 resources to be added, 0 to be changed, and 0 to be destroyed. Terraform apply so that my backend should exist first, then only I can reference it into my projects. So later what you can do is, let me enter the value over here first. So meanwhile it will get created Over here, we have just defined the Terraform backend. You can extend this. Let's say example, you want to create a instance or the VPC or maybe the subnets or security groups. So you can extend this configuration file and add those configurations over here. And in this way, the state file of those configuration will be present into your AWS S3 bucket with the name this one. Okay. Let's see, the resources have been created. Okay. For now, what I will do is let's create a resource which is AWS instance. Okay. And I will say that web is the name. Okay. Let's do one thing. Copy from here. Okay. So this is what we want, so that I can show you that the state is getting stored, right? And this is over here. Now let's do one thing. Okay, cool. Let's get outside of backend, right? Here also, what I need to do is I need to initialize the backend, because previously what we did, we created the S3 bucket and the DynamoDB inside our backend folder. Now this has to be initialized. Let's initialize that, and meanwhile I'll open the DynamoDB as well. This tables, okay, right, in US East 2, okay, sorry, US East 1, and I will duplicate this tab for to see whether S3 bucket is also created or not. So I will go to S3 and open this one. Okay, quickly let's, okay, it is initialized. Clear that and directly hit apply, because I don't think we need to check what resources has to be created. It's already there. We know that AWS instance will be created with the name web server, and see, it says acquiring state lock. This may take a few moments, and this is created. I will just say yes, and want to add 0 to change, 0 to destroy. Okay, let's just refresh this one. Also getting created or not. See, the table is getting created, and it says the Terraform log table, the name of the DynamoDB, which we over here we have defined Terraform log table. It has been created, and also inside this log table you can see that the partition key is block ID and the type of it is string. Okay, cool. Now let's check other things. Okay, we'll need to apply the changes first, right? We already did, and let's see if the S3 bucket has that resource or not. Yeah, so we have the S3 bucket created, and inside this, let's check. Yeah, we have our terraform.tf state file, and everything is there. The bucket versioning is enabled. Okay, now server side encryption is also there. Okay, and we have stored our state file inside this, right? And this state file, what it will have, it will have the configuration of this particular instance, right? So in this way, you understood that how we create the state file. Okay, sorry, how we create the backend and how we store our state file into the backend, right? So let's just quickly understand some few essential commands of Terraform state. Okay, so for example, if you want to list the resources in your state file, right? So for example, let's say you have multiple resources like VPC, instance, S3 bucket, etc., and you want to list out a particular resource, or you want to list out the resources which are present inside your Terraform state, then you can use a command called terraform state list, and it will basically give you the list of the resources which has been created inside your Terraform, right? So this is the one which has been created, and exactly the same which you see over here, and it will be exactly the same where you can find your where you will be able to find your Terraform's TF state file. So you see, for this project lecture 7, you don't see any TF state file, right? Why? Because it has been stored into your S3 bucket, right? Which is why you are not able to check your TF state file inside this particular folder. But you can obviously use the Terraform commands, right? State commands. Okay. The next command is if you want to see configuration of a particular resource, like I want to see the configuration of web server, right? I will say Terraform state show, and I will say the resource is this. We know now, okay? And let's paste this, and let's wait for a while. I think it will give me the configuration. Yeah, you have all the configuration, and this configuration you can access from like when you create the plan, then also you see this configuration. But if you want to see the configuration of a particular instance or particular resource, then in this way you can state the resource configuration. Okay, let's clear this and let's understand the next example or next command. Okay, in case I want to remove a resource from my state file, right? So if you want to remove a resource from your Terraform state only, like let's say the resource is web server and I want to remove it, and you had another configuration as well into your Terraform state file, but one of your web server you don't want to track it anymore, but you want to remove it from your Terraform state file because you think that if I make any changes it may impact my this web server in future. So if I make any configuration changes to other resources, maybe this resource can be impacted, and for now I don't want this resource to be impacted because this is running fine and all the configurations and everything is fine, and I don't want to track it anymore so that I don't make any mistakes in future, right? So what you can do in that case, you can use Terraform state rm and add the server id, the resource name. Okay, the way which we did in before, like if you see in our previous command we used aws instance.web server, right? Similarly you can do Terraform state rm, and your this resource will no longer be tracked by the Terraform state file, but it will be present into your AWS account or in your architecture. This particular resource will be present, but it will not be tracked by your Terraform state file anymore, right? And why we do that, I've already explained the example, that you don't want to track your particular resource, you don't want to make any changes to it in future, and you are afraid of making any mistakes or impacting this particular instance by making any configuration changes to other resources, right? So this is also done. Now let's understand one more thing. The next command is Terraform state mv. Okay, so mv is for moving or renaming your resource inside your state file. Okay, for example, let's say the name of this web server, okay, I want to change it to something else. I want to say to app server. Okay, so in that case we can use this Terraform state mv command, and let's take the example instead. Instance dot web server, sorry, web server, okay, to aws instance dot app server. Now see, something is happening over here. Let's wait. Okay, okay, I just added the arrow dependency. Let's remove this one, and there are two arguments which needs to be present over this command. Let's see if it works or not. Okay, it's working, and now it says moved. Okay, aws instance dot web server to aws instance dot app server. Okay, now I just want to do one thing. I will remove the tracking of this app server. Let's see if it will work or not. Let's wait for some time. Yeah, you can see it is removed successfully, the app server, and now your Terraform state file does not basically track this particular server.
Let's understand what is Terraform modules. Terraform modules help
us organize infrastructure code into small, reusable components. Instead of writing the same Terraform resources again and again in multiple projects, we create modules once and reuse them wherever needed. Modules work very similar to functions in programming languages. So, in any programming language, what you do, you define a function, okay, and it accepts some input variables. You define your code and it returns some value, right? This can be considered as output as well of this particular function. So module also work in a similar fashion where a module accepts input variables, it creates infrastructure resources, it returns the outputs and can be reused across environments like dev, staging and production. So instead of rewriting VPC, EC2 or security group configurations multiple times, we create modules once and reuse them across projects. This makes Terraform code cleaner, reusable, easier to maintain and production ready. Okay, let's understand the problems without modules. Okay, now imagine writing Terraform like this in a real project where you have a main.tf configuration file. You define a VPC over here. You define a EC2, a subnet, and then a security group, your application load balancer, and so on and so forth. So now just imagine you have to create it for multiple environments, which can be your dev environment, your stage, and also somewhat your production environment. Okay, so now you will create dev main.tf, and similarly for stage and prod, you will create the configuration. Okay, you repeat everything 3 times. And now if you want to change or make any changes to security rule, you have to apply it in all the 3 files, right? If you want to add one subnet, you have to make changes everywhere. And if you are trying to fix a bug and you have fixed one bug, then you have to update it in all these environments, right? So this becomes impossible to maintain in real teams. So the first thing we understood is code duplication, where we are just duplicating our code. Okay. Second problem is no reusability. Why? Because let's say you are working with multiple teams in an organization. Okay. So team A wants VPC and team B also wants VPC, right? And team C also wants VPC. And in this way, what you are doing, you are just creating VPC again and again, and all of the teams are using it. But what you are doing, you are just creating it again and again, and you are not reusing your code. Okay, so this is the one of the major problem, and 3 versions of same infrastructure exists in this way. Okay, third problem is no scalability, right? So in our previous examples, we took small projects like creating an EC2, subnets, and adding some configuration for VPC, security groups, etc. But think of it in this way, in enterprise project, there are more than 4,000 lines of code, right? So in this way, what will happen? Nobody will understand what depends on what, where subnet is created, where security group is defined, how DB is connected, and debugging becomes painful. Okay. Now let's understand the fourth problem, that impossible team collaboration. Why? Because everyone edits the same file, which is main.tf. Okay. And the conflict will happen daily. So with modules, let's take an example that network team, if you have introduced modules in your project, okay. So network team, what they will do, they will take care of VPC, your subnet, and other networking components, right? And the security team, what they will do, they will take care of your security group module, okay, where you define multiple rules, you want to add it, you want to remove it, the security team will be responsible for that. Okay. And the app team, what they will do? They will focus on EC2 module only to leverage compute power. Okay. So we understood all of these problems. Now let's see that how we can use the solution for it, right? How we can make a solution for it. And the answer is we use Terraform modules for all of the above mentioned problems. Okay. So modules basically solves these exact problems, and a module is simply a folder containing Terraform files that performs one task at a time, right? And each module have one responsibility, like we have understood. Let's say, okay, let's say module VPC has one responsibility of networking. Module EC2 will have some other responsibility to leverage your compute. And in the same way, for other modules also, there is only one responsibility to perform, and this can be also reused, and the outputs can be also mentioned or used in your main project, right? Now let's take an example, a diagram, and let's understand how the directory structure looks like. You have a modules folder, which can be considered as centralized reusable Terraform modules. Okay. You have a network folder where your network module is there. Example, your VPC, your subnets, and inside the main.tf, you define VPC and subnet. In your variables.tf, you input the variables for VPC setting, and the outputs.tf, you outputs the VPC ID or subnet ID, which can be reused in this module, which is compute, where you are just provisioning the EC2 instance. You are defining the compute configurations, right? And in the output folder, what you are taking the output, it can be your public IP or your instance ID. Similarly, in data module and in any other module, you do the same work, right? You understood how modules directory structure looks like. Okay. Now let's understand one more thing. So there are two types of modules. One is root module and the other is child module. So your root module can be considered as entry point, because over here only you apply the commands like init, plan, and apply. Why? Because this is your main project, okay? And the child modules are actually the reusable infrastructure component, where what you do, you define your module VPC and then module EC2 and so on and so forth, right? So let's understand one more concept, which is called module versioning, and why are IT companies uses versioning. Okay. So let's understand module versioning and how IT companies uses it. Let's understand that. In real IT companies, Terraform modules are shared across multiple teams and environments. So instead of directly using the latest module code, organizations create version tags like version 1.0.0 or version 1.0.1, right? And each environment then uses a specific stable version of the module, and this ensures that production infrastructure never breaks when a module is updated. Why we do the versioning? Because we want to update our modules, and each environment then uses a specific version, okay, so that it can be like our infra can be stable and nothing breaks out, okay? And teams test new versions in dev and staging first before promoting them to production. Okay, let's take an example. Now, a developer creates a module, okay, a developer creates a module and he tests it in dev environment, and he releases a version 1.1.0. Now QA team validates the module and promotes it to staging, environment. And then once the in staging environment, your modules are tested, it is then promoted to production. Okay. So no direct production changes are allowed, right? And in this way, what we have done, we have releases, we have uh, releases which we can tag, right? And also what IT companies do, they basically never use main branch directly. Okay. Also they use semantic versioning like 1.1.0, right? Like we have understood in our previous example, and test in lower environments first, then only it is promoted to production. Okay. And there's one more file called changelog.md, where we store the information that what we have changed inside our module and what is the update we have done. Okay. And also they document the breaking changes. Like if some of the configuration you have updated breaks your environment, then in that case, they also document this breaking changes, right? Now let's directly jump onto the code and understand how we can implement the concept of modules. Okay, so inside lecture 8, you can see there are some files already present. Why? Because I have taken the same example which we have took in lecture 5 and extended it in our lecture 8. Okay. So what I have done, I have just modularized this code, and let's understand how I have done that. Inside the module folder, I have created a folder called module. I have 3 subfolders, which is EC2, network and security. Inside your EC2, what you have, all of the configuration which we have seen in lecture 5, right? And also what we are taking the instance ID as an output. Then we are using a user data script, same as lecture 5. And then we have variables.tf, where we define some particular variables which are being which are being referenced in main.tf in my EC2 folder, right? In a similar way, inside network, I have created VPC and subnet configuration. And inside security, I have created security groups configuration. Okay. So these are the modules which we have. Now our project will be present outside this module folder, where you can see you have providers.tf, you have terraform.tf files. Okay. And this will contain the input you want to pass to your variables.tf file. So this is also we have created in lecture 5. So we will reuse it, and also the variables.tf. Now let's create the main.tf configuration file and understand that how we can reuse the modules inside our main project. Okay. So I will say main.tf, right? And let's do one thing over here, that we are first of all going to call our module called network. Why? Because inside network we have VPC and subnet, and in return this subnet ID and VPC will be reused in my EC2 configuration, which is why the module network will come first. Okay. I will say module network, right? And the source is, it is present inside modules folder. See, in the auto completion, we can see that this is suggesting modules/network. Okay. Next thing is, I am just saying common tags and add var.common tags in this. Okay. We have defined this in lecture 5. If you didn't watch that video, go and watch it, then come back here. You will be able to understand all of this concept. Okay. Now next thing is,
we will define our security group. Okay, and we will say module security. The source is slash module security, right? And I will say that allowed ports are var dot allowed ports, and this allowed ports are basically inside this variables.tf. Okay, so this is defined inside our variables.tf. Also, one more thing we want to do over here is we want to associate our security group with our VPC, right? So in this way, what we will do, we will add VPC ID, okay, and we will say that modules dot network dot VPC ID, okay, and from where it is coming? It is coming from the outputs folder. So over here, what we are doing, we are basically reusing the outputs which have been derived through our main.configuration, main.tf file, the configuration file. And when the EC2, I mean the subnets and VPC is created, the IDs are being stored inside the outputs.tf, right? And we are calling this inside our main project so that we can reuse these outputs inside our example. Okay. Next thing, now we have network module which have VPC and subnet. We have security group. The next thing I will do is I will call the module called EC2, and I will say that the source is slash module EC2, right? Okay. Now other configurations are, we want to also define the environment, and the environment we can take from our variables.tf, right? Now next thing which we do is instance type map, and we will say that take this from our environment file, sorry, variables file. Okay. Then we will define the server names, which is also present in variables.tf file, and the common tags, same var.common tags. Okay. And we will associate our subnet with our EC2 instance by using module.network.subnet ID. And this is subnet ID, the output we have derived from our module called network, right? Next thing is we want to associate the security group as well. So I will say security group IDs, okay, and I will provide a string value over here, which is what I will take the module security and say that add the security group ID of this particular module, right? Now we are done with every configuration, and see, with a minimal code, what you have achieved, you have all the configuration which you wanted to define to provision your resources or your infrastructure, and it is very clean, reusable, and also there are no code duplication. Now let's initialize our backend and let's see if we made any mistake or not. So I have initialized my backend, and see, it is saying that it is installing or initializing the modules which we have defined, and it is also taking the path. It is storing those modules inside this .terraform folder so that it can source those configuration into our main project, right? So the backend is initialized, the provider plugins are there, and inside which you can see the folder modules, right? Now let's do Terraform plan, and let's see that what all resources it is creating. Okay. It's just the same which we have created in lecture 5. You can see we have web server, API server. Okay. We have web server, sorry, the public subnet, and we have web server as well somewhere around here. So let's do one thing. I will apply these changes and see if I am able to leverage the benefit of modules and provision my infrastructure. Okay, so it has created the log here. Okay, I will just say yes, and I will wait for some time. The VPC is getting created through the module.network.aws VPC. See, everywhere you can see the modules are being used. Subnet has been created, and it is creating the web server and API server now. Okay, let's wait for some time and let's log into AWS console, right? And let's just duplicate this for now so that I can also check the VPC configuration. Let's wait for some time. Okay, now I think the resources have been created, right? And just forget this. I'll do one thing. I will add the running tab because it is showing some stale information. Now you see you have your API server and web server. Same we did in lecture 5. The resources have been created, and inside any of the, let's take this example. So meanwhile, you don't see public IP over here because it is initializing. The initialization has not completed, right? If we see, you can see the initializing state, right? And we have associated our main VPC as well, okay? And the public subnet as well, right? So these were the VPC and subnet configuration which we provided. You see, these are the configuration, and the VPC is also the main VPC which we have created. And also, I think the security group is also associated. Let's see. Yeah, we have the security group, we have the port range, we have the source and the security group name. Okay. The tags are also there. Yeah.
Environment management means maintaining separate infrastructure for dev, staging, and production. The two main ways to achieve this are Terraform workspaces and environment folder structures. Workspaces allow multiple environments using the same code base but separate state files, while folder structures create dedicated directories for each environment and are widely used in enterprise projects. Most companies prefer folder based environments because they provide better isolation, security, and CI CD integration. So, first of all, let's understand what is environment management. So, let's say I will create three teams over here. Okay. So, these are the three teams, and I will call them A, Team B, and Team C. So, all the teams are working on some kind of development work, right? And the first stage which they passes through is dev environment. Okay. So whatever work they have created or whatever development work they have done, they will test it out in dev environment first, right? And then the test is carried out in the test environment. So next stage is test environment. Now comes pre-production. Okay. Pre-prod. And then we can say that now the artifacts or whatever findings we have or whatever the development code we have after the iteration or after enhancing the code, we are pushing it to the production, right? In between, what happens, some of the teams or some of the IT companies, what they prefer is they put a stage in between where we can say this stage can be considered as performance stage, where they want to test any feature or do some performance testing. So these kind of steps they take in this particular environment where they do some testing, right, of their code which they have written. Okay. And also for the safety or for the surety, what they do before promoting the artifacts or the code, what they do basically, they introduce one more stage, right, in between, and we can call it staging, right? So from here, what you understood that there are multiple types of environment in a particular enterprise world, where what they do, they push their code, they develop their code first of all, and they do the testing in multiple environments based on their use case. And then it's up to their use case whether they want to promote the artifacts, they want to promote the code or whatever the development work which they have done accordingly. And this can be any name, right? For some companies they can use alpha, beta, and gamma, something like that. Okay, so it totally depends on the use case. But now you have understood what is actually environments and how do people or teams handle the environment, right? So environment management means maintaining separate infrastructure setup for dev, for staging, and for production, which we can also say the application will be uh, used by the live users or the end customers, okay, in the production. So each environment runs independent infrastructure but often uses some of the same Terraform code. Note this, I am saying some of the resources, not all, because a dev environment and a production environment is entirely different when it comes to architecture setup. We will understand this later in this lecture, but let's say you have some of your infrastructure code, okay, where you are using VPC, EC2, and security group and other configurations as well, right? So the same amount of configuration which we have in dev is also in prod, right? The same amount of configuration means whatever the resources we are creating in dev, it is also present in prod. But in dev, maybe your instance could be T3.medium, but in case of production, we want live users to use it and we want to handle the heavy traffic. Then in that case, it can be something like M5.x large or more than that, right? So what you can see over here is even though the resources are shared or being common in dev environment or prod environment, the configuration type of these environment are different and they differ and they have a vast difference. Like it's entirely different from dev to prod, right? So Terraform workspaces help us to handle different configurations per environment, right? And why multiple environments are required? Because without environments, developer tests directly on production, and the risk is you get downtime, okay, and also security exposure is there, right? You can have some broken deployments because dev have low configuration, right? And you don't have your enhanced code into your dev environment, and if you want to directly jump into and deploy your code or your application to prod, then you can have some broken deployments, right? Because you have not done enough testing, right? There can be some data loss as well. And with environments, you move progressively where first you test your code, your application in dev, then in staging, and then in prod, right? This is the flow which is followed by every team, right? So there are two common techniques. So let's understand this. There are two common techniques which are being used by the IT companies. Okay. And let me tell you that today we are not going to put a lot of emphasis on Terraform workspaces. Why? Because the major IT companies and their major projects, infra projects, they don't use Terraform workspaces. This is a clear signal that they don't use Terraform workspaces, rather they use environment folder structure. And for the understanding part, we will put a lot of emphasis on environment folder structures rather than Terraform workspaces. We will take an example code of Terraform workspaces just to understand the concept of workspaces. But today, the agenda is we need to understand how IT companies manage their uh, multiple environments, right? Because you are going to work on any of the IT company, and if you are working on some major project, then you should have this information first, because there can be a lot of areas where you can make mistakes. So which is why environment folder structure is very necessary to understand. So for now you have understood the two types are Terraform, Terraform workspaces, and the second is environment folder structure, right? So first of all, let's discuss what is Terraform workspaces. Okay. So Terraform workspaces allow multiple environments using the same code base but different state files. Okay. Example could be, let's say you have main.tf file. So let's say this is your project. Okay. This is your project, and inside which you have main.tf file, you have variables.tf file, then output, right? And also, sorry, okay. And also you have your Terraform.tfors, or maybe your backend as well. So all of this information or all of your configuration is present inside this project, right? Now, what you want to do is the same configuration which you are using over here, you want to deploy it on dev, then on stage, then on prod. So let's take three examples only. And dev will have a lower configuration, right? Stage will have a bit higher, and then production will have the highest level of configuration of any of the resources you are using in your project, right? So in this case, what Terraform workspaces do with the same folders or files within the same folder structure, what the Terraform workspaces do, it creates multiple environments, right? Dev, staging, then test, or maybe perf, other or other thing is prod, right? So with the help of Terraform workspaces, you can introduce multiple environments, and all of these environments will be using the same set of files or configurations present inside your project, right? Now you understood. And how we can do this? By using Terraform workspaces command, we can create multiple environments. Okay. And each workspace has its own state file, own variables, and infrastructure code, right? So let's take this example in this way. You have your configuration files, right? Which will be common for your all of the environments. Then you have multiple stages, which can be also called environments, right? So first is your dev environment. Second is your staging. Okay. And third will be your prod, right? So each of the environments, what they will have a different set of TFORs plus backend dot TF, right? Same thing will be here, and it will be different from what is in dev. Similarly, we will have this defined into our prod as well, right? Backend dot TF. Now, what happens is basically all of these environments are handled through multiple state files, right? I mean, for the multiple state files, what I mean here is dev will have their dev state, right? Dev state, and stage will have stage test, oh, sorry, stage state, and similarly in prod, right? So each of them have different states, and these are being handled or stored into S3 with a bucket called dev bucket, and over here it can be stage bucket, okay, and this can be your prod bucket, right? So these states will be stored in different S3 buckets named by the environment name, because they want to basically isolate each of the state file from multiple environments, so that the configuration for dev will be applied to dev only, and the stage will be applied to staging, and the prod is applied to prod, right? So by default, what Terraform does, Terraform automatically creates infrastructure for dev environment. So whatever we have done so far, right? Whatever we have done so far, whatever the examples we have took, these are all being deployed into an environment called dev, right? So it automatically creates that infra for dev environment only. Now let's see what are the advantages of workspaces. Like I said, first advantage is you have single code base, which can be reused in each and every environment, right? The second is you have the benefit of multiple environments. You can create your environment by any name, right, with the Terraform workspace command. Then you have separate state files, right, which will not confuse you with the configuration of multiple environments. And it is also important to handle different state files for different environments, and placing them into different buckets, because this is very crucial file, right? We have understood so far that why a state file is very crucial and why is it very important. Also, the setup is very quick. I mean, you just need to create a command, right? You need to just create environments, and you have a single code base. You just run the commands and you will be able to create multiple environments. Now, it is ideal for small setup. Okay. All of the benefits which we have talked about is ideal or is beneficial for the small setup. But what will happen if we have a big setup, right? In enterprise world or IT companies have a very large projects and very vast number of environments. There are at least 8 to 10 environments in a very big scale project, right? So in that case, what will happen? We follow a technique, right, which is called environment folder structure. Cool. So this is an industry standard. This is the most common approach used in real DevOps teams. So instead of switching workspaces, because what will happen whenever you create workspaces, right? Dev, stage, and prod. What you need to do is whenever you want to deploy your configuration or provision your resources for dev, you need to switch it to dev environment. Then if you want to do it for stage, then you will have to switch it to stage, and then to prod if you want to deploy your resources to prod environment, right? So uh, you have to multiple, like you do multiple switches over here, and there can be a huge error which you can make by switching your environment, and this can be a very common mistake, right? So what we do, we introduce this environment folder structure, and each environment has its own folder. So workspaces mainly separate state files, not infrastructure architecture, right? And also they do not uh, separate the permissions or execution pipelines. Think of it in this way. I have a, right, we took this example, I have a single code base, okay, and this single code base is running in each and every environment: dev, test, perf, stage, right, and then prod. So what will happen over here is your state file are being managed by different work, like using Terraform workspaces, your state file is being managed differently, but not your infra code, because you have a single code base, right? So this is being reused in every environment. Okay. And what will happen is, if you want to create a different set of resources for a different environment, let's say your prod have ALB and your WAF or some other configuration which you don't want to be present in dev environment. What will happen? Then you have to create a lot of conditional based expressions where you will say that if workspace is equal to dev, then do not deploy all of these resources. And if it is prod, then only you deploy these resources, right? So this is very error prone, as you can see, because your single code base is handling all of this situation where it can make your code very complex, right? And also, whenever you are deploying your or provisioning your resources into different environments, what you are doing, a single person can access any environment, right? So there is no level of permission set over here, okay, which can also be implemented using the execution pipelines. And if someone is executing any pipeline, then he or she can directly go and switch the workspace and deploy it. But this should not be the case, right? So to understand this, we will understand some of the limitations of workspace. Then only you will be able to understand why IT companies go with the environment folder structure rather than Terraform workspaces. Okay. So the first thing which we understood is difficult for access control. Why? Because let's say your dev team have some developers, okay, and staging is taken care by QA team, and prod is only taken care by DevOps or your SRE team. With workspaces, what you do, you just select the environment, and the particular individual will have access to each and every environment, right? Or and he and she can deploy the resources or provision the resources in any of the environment, right? So anyone with repo access can switch to prod workspace and apply changes. There's no built-in permission boundary. In real enterprise requirement, companies enforce rules like developers cannot deploy to production, and only SRE team will have the production access and the security approval required before prod changes. So workspaces cannot enforce all of these, which is why we have folder based environments where I will say in environment, right? I have a dev folder inside which I have my configuration files. Then we have the stage as well, and we have the prod as well. So see, environment folder will constitute dev, stage and prod folders, and inside which different configuration, like different set of configurations and permissions will be applied to each and every folder, right? And access control can be applied via get permissions or IAM roles or CI/CD policies or approval workflows, right? So dev team will be only able to access the dev folder, and the prod team, I mean the SRE team, will be able to access only the prod folder, right? So we have limited environment customization, and this is our second limitation, which is limited environment customization using workspaces, right? Why? Workspaces assume environments are mostly identical except for small parameter changes. Example workspace usage is if you take an instance type and you say inside instance type you pass your workspace, right, value. For example, it's dev, stage, prod. It can be changed according to whatever input we provide, right? So it will work fine for, let's say, dev, right? And also, let's say for prod also it is working fine, but fails when environments differ structurally, which means that whatever the example I have given over here, that let's say your prod have multiple resources and these are being wired into each other, or the dependencies are wired in such a way that it is entirely different with dev. Then in that case, what will happen? Because of single code base, your uh, provisioning of resources will fail, and you'll be making a big blunder over here, right? So real enterprise scenario production often includes your NAT gateway, or maybe WAF, or maybe load balancers, some monitoring stacks, right? And all of this is not required in dev. Why? Because we are just doing a basic testing over here in dev environment, just on to progressively move to next environments, and over there we can just increase the configuration, increase the the type or size of the configurations, and also the architecture can differ based on the environments. As we go ahead with the progressive environments, the architecture will get complex, and your infra architecture will be much more complex as compared to dev in prod, right? So that is why we say that there are huge architectural differences and not variable differences when we compare it to dev to prod. Third limitation, right, which is it is very harder, it is very hard to implement, or let's say harder CI/CD integration. Okay. First problem is, let's understand the first problem in the CI/CD integration part. Right. The first problem is pipeline must manage workspaces by switching the logic. So switching the logic, I mean, if you want to switch to dev and if you want to switch to prod, then in that case, you will use Terraform Workspaces command to switch to that particular environment, which adds complexity. And the problem two is parallel environment. Parallel environment deployments become risky. So parallel environment deployments are risky over here because, for example, pipeline 1 is running dev and pipeline 2 is running prod. Both share same code directory. State conflicts could be possible over there, right? And the third example is it is very harder audit tracking. So enterprise wants logs like who deployed staging, who deployed production, and which version was deployed. So these kinds of audit control is taken away with the Terraform workspaces. And then we will understand our fourth limitation, which is risky for production, risky for production isolation with the other environments. So production infrastructure must always be fully isolated. And enterprise requirements are, for example, they want separate state files, separate IAM roles for multiple environments, separate pipelines for different environments, and they also require separate approval workflows. So for example, if you are just if you want to provision resources and there is a step where manual approval is required, then in that case different sets of managers based on their hierarchy will be approving your workflow so that you can apply the changes. So let's say a higher level of manager is uh, like associated to do the manual approval for the prod, and your basic manager or low level manager is associated with dev so that you can provision the resources, because there should be a manual check always before provisioning your resources. Like I said, there can be security constraints, and also it comes with a cost, right? And also for dev environment, production environment, or staging environment, you need to basically have separate secrets. So what we have understood, I will just add a subtopic, and these are the separate things which basically IT companies need in their infra provisioning capability, which is separate state file. We understood this. Separate IAM role, okay, and separate pipelines so that they can differ each of the environment, okay, separate approval workflows based on the hierarchy, and separate secrets, right? Because the dev environment must be having different secrets as compared to prod, right? And the prod will have a very high level of secrets which are very crucial for your application to run, right? And it is also very confidential. Also, they want a different backend storage. Like I said, every environment, dev, stage, test, every environment will have a different storage, dev bucket or stage bucket, something like that. Okay. So workspace only isolate the state file. So the problem is workspace only isolate the state file and it does not isolate all of these things, right? The same repo, same execution path, same credentials, same pipeline logic, and this increases the production risk, right? So now let's understand how actually IT companies are making their directory structure. Okay. So let's say you have a root directory over here, inside which you have your infra repo where your main project is there, right? And inside this, you have modules. So if you don't know about modules, then go and watch the previous lecture. We have understood what are modules and how they are used or implemented in Terraform, right? And this modules will have your VPC, your EC2, your SG, or other things, right? Then comes the environment. Okay. So at the same level, you will have an environment folder, right? Inside which you will see multiple environments like dev, and dev will have main.tf, okay, and variables.tf, then backend.tf, then your provider file, then also you have terraform.tf, and this is being replicated in each and every environment. So the same set of configuration file will be replicated in stage, okay, and in prod as well, or based on what are your requirements, right? So over here, what we do, we reuse these modules, and we can say that these are reusable modules, and these reusable modules are basically called inside every environment where we are defining our basic configurations, right? So in the previous lecture, we understood how we can call the modules from a different folder. So in the same way, over here, what you are doing inside every environment, you are just calling these modules, and this can have a multiple modules, right? ALB, or it can have WAF, or n number of modules you can create over here. So let's say if in a dev environment we don't want WAF and ALB, so we will not call this. But in prod we want this, which is why we will be calling each and every resources inside, or each and every modules inside the environment folder or configuration file, right? So the environment promotion workflow, I want to uh, like show you guys. So this is how the environment workflow takes place from development to prod. Okay, I'll be committing this to the GitHub repository. You can take a look and you'll be able to understand how the actual workflow takes place in IT companies, right? So we have had enough of information about environment folder structure, why IT companies use them, and also we understood what are Terraform workspaces. In our later examples or in our projects, we will take the example or take the leverage of environment folder structure, and we will create a enterprise level of setup. But for today, let's understand the Terraform workspaces, where I'll be just covering an example code on Terraform workspaces, and we will also see what kind of different Terraform workspaces commands are present over here, right? And even though workspaces are not majorly used in IT companies, but companies use workspaces for small teams, for learning projects, quick environment duplication, and POC setups, or maybe if you want to set up a temporary environment, right? Which is why this concept is also very important to understand Terraform workspace, right? We will take an example code and understand how workspaces are getting created, and there are multiple commands through which you can play with your Terraform workspace. Let's start, and inside lecture 9 folder, okay, let's create a one folder which is called workspaces, okay, workspaces demo, inside which I will create three files, which is main.tf. I will also create variables.tf, and one more thing is you have outputs.tf, so that we can see that which environment is being particularly used at the time of deployment. Okay, so let's start with variables.tf, and over here I will say variable instance type, and this will be a map, right? Why? Because we want to choose multiple environments, and this can be stored into map, where we will say for dev use t2.micro, for staging use t2.small, and something like that, right? And we have done this in past, where we have created the instance type using map. Okay, so let's say map of string I want to use, and the default value to it will be dev will have t3.micro. Okay, your staging can have t3.medium, and your prod will have m5.xlarge. I think this is the only configuration. Let's see, m5.xlarge. Let's check this table m5 d.xlarge. Okay, use this over here m5 d.xlarge, and we are done. So we are just taking a basic example over here, right? We are just creating an EC2 instance. When we will create a actual project, then we will be using a complex level of example, and we will see how enterprise applications are being created, or how enterprise infra is actually provisioned. Okay. Next step, let's define main.tf quickly. I will say provider, and I will use the basic syntax of provider, which is AWS, and the type is, sorry, the region is US East 1, right? And let's do one more thing quickly, just create our AWS instance, and I will call it web, our favorite example, and AMI, let's take it from over here, sign in again. Okay, we can take this from our previous example as well, not an issue. Inside EC2, I will go and take this one, right? And here's the one. Okay, for instance type, I will say that, if you remember, we used a function called lookup. Okay, and I will say var.instance type. It should take the instance type from variables file, and also one more aspect, which is terraform.workspaces, right? So in this way, it will be able to understand that we are using dev or stage or prod. So whenever we use Terraform CLI commands and we switch to multiple environments, this value automatically gets updated according to the environment. Okay. And I don't want to put a tag, but let's do one thing. I will say that name is uh, workspace demo. Right now, this is done. Okay. So quickly, let's do one more thing. I want to basically take the outputs out from it, and I want to understand that whether the uh, environment which I have chosen, so I want to find out that value as well. I will quickly just do output workspace, and I will say that value will be terraform.workspace. Okay, and also what kind of instance is being spin up by choosing the environment. I want to take that as well. So instance type use, I will say, and I will do value is look up to the value of what we have in var.instance type, as well as what type of environment I have chosen. Okay, so let's do one thing quickly, go inside this folder and do terraform init. Okay, cool. So we have our backend initialized. Now let's do one thing. I will use Terraform workspace command, and to create a new workspace, I will say Terraform workspace new and dev. And see, it says that created and switched to workspace dev. Okay, so let's do one more thing. Let's create one more environment, just to take the example, and let's check which environment, like which all the environments which we have created. So there's a command called terraform workspace list. See, so we have default, right? This can be also considered as dev, just because we have created a new environment called dev, so that, which is why we can see the dev as well. But by default, like I said, Terraform creates a dev environment, and we work into that environment. But now we have these three environments present over here, and currently we are in stage environment, right? But we want to spin up the resource for dev environment. So in that case, there's one more command which we can use, which is terraform workspace Okay, and select is the environment by which you can switch to multiple environments. Okay, so I will say dev, let's wait. Okay, so it says that we have switched to workspace dev, right? Now, one more thing is there. If you want to uh, delete any workspace, then what you can do is you can run one more command, which is Terraform workspace delete, and I will say delete the stage workspace. Okay, so the stage workspace is deleted, and this star basically represents that on which environment you are switched to right now. Okay, so if I once again do Terraform workspace list, I will have default and dev only, and this star represents that I am in dev environment. Cool. Now let's just quickly apply the changes rather than doing the plan, because we know we are just spinning up a simple instance. And I will say yes. See, you have output over here which says that instance type which we are using is t3.micro. Why? Because we are using dev environment. Okay, and in our variables file, what we have stated that use t3.micro if we are using dev environment, and this value which we see over here, Terraform.workspace, it is automatically taken from the value which we have switched to, I mean the environment which we have switched to, right, through the terminal. And see, we have outputs over here. The workspace is dev, which we are using, and the instance type used is t3.micro. Okay, so today we have understood what is workspaces and what is environment folder structure, which is very important, right? So you need to understand environment folder structure and the workspace for small scale of applications or for small teams. Okay, Terraform manages real infrastructure, not just code. That means whenever you provision your infrastructure, you may have credentials, database passwords, API keys, certificates, or access tokens. And it can accidentally leak if not handled properly. So, one exposed.tf state file can compromise your entire cloud environment. So, security must be built into your variables, right, which you define, and your state storage. For example, you take S3 and you add some restricted policies using IAM, right? And then we have secret management, okay? And then we must have one validation pipeline as well, where we can validate that none of our secrets are getting exposed and we don't have any security vulnerabilities. Okay, so handling sensitive variables in Terraform is easy, and Terraform provides a built-in way to mark variables as sensitive. So inside your variables.tf, let's say you want to define your DB password, okay, which you want to use to log into your database. Okay, so I will say DB password, and then I will add the type as string. And the next thing is you want to add a value which is called sensitive, and you must mark it as true so that this DB password will be masked and it will not be exposed in your CLI or in any way, right? But this value can be exposed in the form where you will pass this value inside terraform.tf files, and then you will just commit that terraform.tf files inside your repository. Then in that case, your value will be compromised or your password will be compromised. So what Terraform does? Terraform will hide value, hide value in CLI. So you will not be able to output this or you will not be able to see this. Also, it prevents accidental logging and it reduces the risk of exposure, right? So this is one way. What could be the another way? Because the important point over here is secrets are still stored inside state file. So this is not enough alone. Even though you are using this sensitive as true value, but still whenever you just apply the changes, then your state file will include this information, include this password. Then what do we have? So we want to understand the best practices to manage our secrets and sensitive informations, right? So first of all, you must never hard code secrets and instead integrate secret managers. So first point is never, never hard code secrets. And what all options we have in the market for secret managers? First is called HashiCorp Vault. Okay. And this is best when you have a multi cloud setup or you are using some enterprise infra. Okay. And dynamic credentials are needed. Dynamic credentials mean you want to derive the credentials by the capability of HashiCorp Vault and you don't want to create your own credentials, right? So Vault has the capability to generate temporary credentials dynamically. Now, second thing which we have in the market is AWS Secrets Manager. Okay, and we have built-in library, or we can say we have built-in functions in Terraform by which you can call this and also create the secrets manager and add your secret ID and other information, right? You can also provide the policies over there. Okay, so this is best for AWS native deployments. Okay, and if you want to store some credential for RDS or AWS Lambda, right? Now, the third option which we have in the market is Azure Key Vault, and it is similar to AWS Secrets Manager. So we will not discuss more about this, but it works in the same way. Okay, so if you want to see like how we can implement AWS Secrets Manager inside our Terraform code, then you must do one thing. Simply just go to web and search for Terraform code for AWS Secrets Manager. Okay, so the first thing you get over here is this one. Go to the official registry, and over here you can find n number of argument references which you can pass, right? And by this you can define your resource and it will have a number of policies over here or arguments, right? So you can see this and implement this inside your Terraform code, right? Let's move to the next point. Okay, the second point is we should avoid storing secrets. Okay, we should avoid storing secrets in state files, right? Why? Because we store these state files inside our bucket and we commit this state file, and if you add or if your passwords are leaked into your state file, then in that case you can have some security vulnerabilities. Okay, so state file basically contains what? It contains resource IDs, it contains passwords, it can contain your connection string to the database, right? And your resource metadata. Okay, so if committed to GitHub, by chance, if you commit this to GitHub, then you could have a security breach. Okay, so what are the secure solutions for it? The secure solutions are, let's take an example in AWS, and I would say use remote backend. And we have understood this in lecture 7 that how we can use remote backend, right? And secure backend encryption is the best practice where the recommended backend setups are, we will take an example of AWS, and in AWS we have S3 plus DynamoDB is the best setup to secure your passwords and sensitive informations. Okay, so in S3, what you can do, you can encrypt your data, right? And also you can version it, Okay, you can version it. The next thing you can do is you can add IAM policies to your S3 bucket so that an unknown person or an unauthorized person could not access your S3 bucket and your state file. And then you can add a mechanism of locking using what? Using DynamoDB, right? So this is what we have understand, that how we can secure our solution. And in the example of AWS, this is the best way by which you can secure your passwords, your state file, and all of your metadata, connection strings, etc. Right? So moving ahead, what we can do is we will understand the concept of Terraform testing and validation, because this also provide a extra layer of security to your infrastructure code, right? So before running Terraform apply, what you can do is you should always validate your code using some of the commands like Terraform fmt, which means format, and it is used for formatting. Okay, and then we have Terraform validate. This is used for syntax checking, right? And then we have tf lint, which is basically used for linting. And also one last thing is checkoff. So checkoff basically is a tool which can be used for security scanning, right? You can integrate checkoff as a tool inside your infrastructure. You can install this and then you can provide this information or its configuration inside your Terraform code, and it will do the security scanning. Okay, so the first example which we took for FMT is formatting actually does what? It resolves or fixes your spacing issues, your indentations, okay, and also your alignments. Now, next thing is, so we can understand that this formatting is very helpful when you have the habit of not making a proper indented file, or you have a problem of creating a lot of spaces or adding a lot of spaces or alignment issues. So formatting is very useful in that case, and it can be useful inside your CI pipelines, right? You can add an additional step before you apply, right? You can add this step so that you can format your code properly, right? It can be useful in pre-commit hooks as well before raising any PR or something like that, and also in team environments. Okay, so next thing is the syntax checking, and the command for it is Terraform validate. So this help you to fix your syntax errors, your invalid arguments. Okay, and next thing is if you add some missing providers, right? And it even runs without connecting to cloud. So even if you don't initialize your backend, then also this Terraform validate command will run, and it will check for your syntax errors, invalid arguments, and missing providers, right? So the linter which we have, the Terraform linter, what it does, it basically detects unused variables. It also detect deprecated deprecated syntax. Say for example, you were using an older version and you have upgraded to a newer version, and over there you were using some syntax which was deprecated in the newer version. So it also checks that and detects that. Okay, it also help you to check if you have provided an invalid instance type or you did some provider mistakes. Okay, provider mistakes. So the example by which it basically detects all of this information, it provides you the warning, and it can be very helpful in prod pipelines, which means production pipelines. Okay, so let's understand Chekhov. So Chekhov, like I said, is a tool which basically what it does, Chekhov is a static code analysis tool for scanning your IAC files and for misconfigurations that may lead to security or compliance problems. Chekhov scans Terraform for security vulnerabilities automatically, like for example, you have opened any wrong port in security group, right? You have defined your S3 bucket as public S3 buckets, okay? And you have some unencrypted storage, or maybe you have some IAM wildcard policies, which means wildcard policies means you have some loophole by which any person can basically access your infra. And we use this tool by first of all installing it, right? We install it and then we use checkoff -d dot and whatever your additional arguments are. Okay, so I will do one thing. I will basically go to checkoff official talks, right? And over here, let's see what we have. So this is policy as code for everyone. Okay. Now it says that these are the ISE types which are supported by me, and you can read through it. You can also define your custom policies based on like what are your requirements, and the custom policies can be defined through Python or YAML. Okay, and the compliance has the industry standards. Now let's see what all we have over here. Okay, so one more thing I can do is check off, or maybe what I will do, I will say CKV AWS 20. Okay, and let's see what it is. Now let's see inside this, or maybe let's do one thing, AWS 6. So I will say what is CKV AWS 6, right? Let me just go through that. Yeah, this is the one which I was looking for. So basically, Chekhov provides you the ID by which it identifies what kind of security mishappenings are inside your infrastructure repository. Okay, so it basically have the ID for say if you added your Chekhov tool inside your infrastructure code, what it will do, it will scan your code and it will uh, present some logs, and inside that logs you will see these IDs. Okay, so if you see CKV AWS2, which means what? Inside your elastic load balancing, something is mishappening or there are some security gaps. Okay, and the policy says that ensure ELB protocol is HTTPS. So this is the policy which defines that what is missing or what is the mishappening going on inside your repository, I mean your infrastructure. Okay, and there are different kind of IDs. If let's say if you have some issues with bucket, then it will throw this error and it will say that you have to fix this, then only you can move ahead. So this is very useful, and like I said, it can be used in, or it can be supported by Terraform, Kubernetes, CloudFormation, your Helm. So this is a very powerful DevSecOps tool. Okay, so we are today not going to take any example code. Why? Because what I will do is basically when I will create a project, okay, in that I will use AWS Secrets Manager as an example, because it will be a very small example if I take an example code right now. And also there are some complications while basically implementing the checkoff. So for now, let's not take this because we don't have enough information, or you can say enough configuration inside our code. So for that, we'll need to add a lot of codes and lot of, I mean, resources which has to be tied into a proper structure or an architecture so that we can use the capability of Chekhov and exactly find out what all are the issues. Because if we take a small example, then in that case, what will happen? It will just show you some of them and you will not be able to understand it properly. Meanwhile, these testing and validation commands, which you see, you can basically imply that imply this inside your repository, and you can find out whatever mistakes or issues you have created. Okay, you can try and test all of these testing and validation commands by yourself. Terraform lifecycle rules let you control how Terraform creates, updates, and deletes infrastructure resources. They are especially useful in production environments where accidental deletion or downtime can cause serious issues. Lifecycle rules are defined inside a resource block called lifecycle. You can see over here, and it has three rules. One is create before destroy, second is prevent destroy, and third is ignore changes. One by one, let's understand each of them, and let's move ahead with the first one. Okay, so create before destroy basically avoids your or prevents your downtime. Normally, when Terraform replaces a resource, what it does, it destroys your old one and it creates the new resource. Okay, so for example, in production, you have a server which you want to upgrade to some larger configuration size. So in that case, what will happen whenever you will hit the Terraform apply? What it will do, it will basically delete or destroy the old one with the lower configuration and it will create the new one with the higher configuration. And meanwhile, during that duration, what will happen? You will face a downtime. So Terraform lifecycle rule of create before destroy reverts this cycle where it first creates the new one. Okay, it first creates the new one and then only it will destroy the old one. So it just reverses that cycle. Okay, and where can be helpful? It can be helpful when you want to achieve zero downtime deployment. Okay, the next thing is if you want any safe resource replacement, right? If you want to make any replacement to any resource, then it can be helpful because the create before destroy, first of all, create the new one and then only destroy the old. You know, right? Now, the third point is it is production friendly. Okay. So it is mostly used in production environment and it helps you to scale your infra or create new resources without downtime. The next thing is we want to understand the prevent destroy, and prevent destroy basically allows that the Terraform resources should be prevented from deleting the important infrastructure accidentally. So Terraform blocks the deletion and you will directly see the error that instance cannot be destroyed and resource has lifecycle dot prevent destroy set. Okay, so where it can be helpful? It can be helpful when you want to protect your DB, your storage buckets, your state buckets, or your production VPCs, right? And your secret managers as well. Okay, now we will move ahead with the third one, ignore changes. So basically ignore changes is for ignoring the external modification. So sometimes what happens, resources are modified outside Terraform, such as manual console edits, your automation scripts or your external tagging tools and some of the security agents as well. And you want to ignore those changes inside your Terraform state file. So without ignore changes, if you don't apply this lifecycle rule, what Terraform will do, Terraform will detect the drift from whatever external factor there is. Maybe it can be a manual edit or an automation script which is creating uh, a resource change with what you have inside the state, with what you have in your actual infra. So in that case, Terraform will detect this drift and it will try to revert the change, right? And you don't want that. Why? Because I will take an example. Let's say you have placed an auto scaling group, okay, inside your in front of your EC2 instance. Okay, then in that case, if you scale your instance, then Terraform will detect that drift and it will try to revert that. And you don't want that, right? Because you have put the auto scaling with any reasons and you don't want to track that. Okay, so in that case, the ignore changes will be helpful. Second is
if your policy are modified outside or it modifies your tags automatically, then in that case also you want to ignore this change. So you will use ignore changes. And let's say if your external scripts are making any changes to your metadata, your resource metadata, then also you want to ignore the changes. Okay, so now you have understood that create before destroy avoids downtime. Okay, prevent destroy protects your critical infra resources, and ignore changes basically ignores your drifts. Okay, with the example code, we will understand all of these lifecycle rules and why this is important. Okay, so quickly, I will create a main.pf file, and let's do one thing. Let's add the configuration of lecture 2 to this one, because I just want to apply the lifecycle rules and keep the example basic. Okay, I will change the reason because I am getting some issues in US East 1. So I will keep it AP South 1, and let's add a block called lifecycle. Okay, over here I will say create before destroy as true, and also I will use ignore changes to tags. So let's say I go to the AWS console and manually changed my tag name from Terraform EC2 example to Rahul EC2 example. Okay, that then in that case, I don't want my state to track that, and I don't want that changes to happen. Okay, so in that case, I will add the ignore changes and it will ignore any tag change happening. Okay, now next thing, what I will do, I will, okay, I will create a S3 bucket and I will name it Terraform, sorry, Terraform state. And the bucket name is bucket, okay, bucket. Okay, I just want to remove this one. And then the bucket name is, I want to keep it unique. So I will say practical, I will practical 11 state bucket. Okay. And here also I will say lifecycle rule is what? I will add prevent the destruction of this particular bucket. Why? Because it contains my state file and I don't want it to be deleted. Okay, now we have all the lifecycle rules applied. Let's quickly initialize the backend. And when the backend is initialized, when we apply the changes, then this particular resource will spin up, or this EC2 instance will spin up. And what will happen? It will create a EC2 instance with t3.micro configuration. And the next time when I will change this instance type, it should apply this create before destroy lifecycle rule. So quickly, I will say Terraform apply, and let's wait for some time. Okay, I just want to accept this change and I want to create the resource. Let's wait for some time. So guys, I was getting some issues with region AP South 1 as well. So I've changed it back to US East 1, and now the resources creation have been completed. I have created the EC2 instance as well as my S3 bucket. Okay. Now what I will do, I will change the instance type to small. Okay. And let's see what will happen. And I will apply the change. Let's wait for some time. And I hope it gets quickly covered. Okay, it is saying that it is refreshing my state, and it is saying that you want to make a change to your instance type from t3.micro to t3.small. Okay, now let's approve this request. Okay, now you see the resource has been modified. Now let's go over here and let's see. Okay, so it is first running this one, okay, which is t3.small with the configuration type, and it has terminated the old one, and we can see both of them, right? So this is the power of create before destroy. Now let's do one more thing. What I will do, I will just add a state first running one, and this is the one, and I will change the tag name. Okay, uh, let's do one thing.
full. Right? Now let's again apply Terraform command and let's see what will happen. Let's wait for some time and it is trying to refresh some state. Let's see. Okay, so it says that Terraform has compared a real infra against your configuration and found no differences. So no changes are needed. Even though I have added this, okay, then also it is saying that no changes are needed. Now let's do one thing. I will just comment this out, okay, and let's see what will happen. So with the help of ignore changes, what it was doing, it was not detecting the drift from manual edit and the what we have in state file. Okay, now you see it is saying that you have made any change and it says that your tags have been changed, right? So this is the power of ignore changes where I was trying to ignore any manual change from AWS console. And now when I have commented this out, it is saying that you have changed it somewhere and the Terraform is detecting the drift. I will say no. And let's do one last thing. Okay, I'll clear the terminal first. And let's do one last thing, which is Terraform destroy. Now wait for some time. And according to this rule, it should not allow me to delete this S3 bucket, right? Let's see if it happens or not. Yeah, it says that instance cannot be destroyed because your Terraform S3 bucket state, sorry, S3 bucket dot Terraform state has lifecycle dot prevent destroy set, like I've explained through the whiteboard. So this is the same error which we can see, and it is not allowing me to destroy. Okay. Terraform provisioners let you execute scripts during or after resource creation. They are useful for last mile configuration, but Terraform recommends avoiding them when possible because they break infrastructure as code practices. Okay, let's understand what provisioners are, their types, examples, and why they are considered as an anti pattern in the world of Terraform. So, again, what are Terraform provisioners? The provisioners let you execute scripts or commands on your local machine or on a remote server, okay? Or maybe if you want to copy some files to your infra, right? So the example workflow could be, let's say if you are creating a EC2 instance, right? And you want to run a script, an installation script onto that EC2 server. So let's say you want to install Flask on EC2 server, right? So you will use the provisioners and then you will be able to install the Flask onto that particular EC2 machine. So what it does, it will install your software, right? And they run after resource creation, which means whenever your EC2 will be created, then only it will run. Optionally, you can run it before deletion, and also it runs only once, which means it cannot be continuously managed, right? So like I said, here are some examples I have already prepared for you guys. So the local exec will run on local machine, correct? And remote exec will run on remote server, right? And file provisioner could be helpful when you want to copy some files onto your server. Maybe it can be your configuration file or maybe it can be your app file, right? So let's understand first local exec provisioner. So it will run commands onto your local system, not inside the resource you have created. Okay. So the example is over here. You have created a EC2 instance and then you want to, after that, you want to run a playbook. Okay. Deploy.yaml is the playbook which you want to run. So it could be helpful in these situation where you want to run um, any of the commands or any of the deploy or playbook or something like that, then in that case local exec provisioner is the best for you, right? And the use cases could be, let's say if you have deployed your application and after the application is deployed, you want to trigger a Slack notification, right? So first use case is this. Then let's say you want to update your inventory file. So suppose you have your Ansible playbooks, right? And after you create this particular EC2, you want to add this EC2 instance configuration into your inventory so that next time whenever you run any Ansible playbook, the this particular EC2 instance should exist inside this inventory. So it could be helpful in that case as well. Okay, you can call deployment script as well. Deployment script after this, and you can run CI/CD automation script, right? So for example, after your resource is created, your EC2 instance is created, what you want to do is you want to deploy a app, right? And in that case, after this resource is created from your local, you can deploy a script which can deploy your application. Correct? Now, here comes the Remote-Exec provisioner, where it runs commands inside the created resource via SSH, okay, or via WinRM. So, suppose your EC2 instance is created and you want to do some installation, right? For example, you want to install Nginx. Then in that case, what will happen? It will particularly make a connection using the type SSH, and you will provide the user, your private key file, etc. And then in that case, what it will do? It will SSH into your instance and make a remote connection, and then it will install the particular updates or whatever you want to install, right? So in this case, remote execution is very helpful, and the use cases, like I said, it is very helpful to install some packages, right? It can configure services as well if you want to configure some kind of services. Then it can start your application, okay? And also you can use a bootstrap server as well, right? Now the next thing is you have a file provisioner. Okay, whenever you want to copy some important files or your application files or maybe some artifacts or supporting information to run your app, then in that case what you can do, you can copy file from your local machine to remote resource using the file provisioner. Okay, and similarly, what you have used in Remote-Exec, you can also use it over here. And what you can do is, we have provided connection over here. Similarly, you have to provide a connection and your private key so that the file provisioner can SSH into your VM, right? The use cases could be you want to copy config files as discussed. Okay, you want to upload some scripts which are required for the deployment or maybe for running your application or building your application, or maybe you have some cron scripts which you want to deploy or run into your machine, your remote machine. Okay, next thing is you can transfer any certificates which you want. This can also be considered as a useful use case, because SSL certificates are very necessary when it comes to a real world application. Okay, and also you can deploy the artifacts by copying the artifacts into the remote machine, and then in that case what will happen, you will have your artifact files ready into your machine with the file provisioner, and you can deploy those artifacts. Correct? Now, provisioners can also run during destroy, and this is a advanced feature where provisioners can run before a resource deletion, right? So for that, an example could be provisioner local exec. This is how you define your resource, and then you will add a condition that when you want to run it, whenever you want to destroy a resource, and you can add a command over here. And let's say over here I am saying rm-rf star dot logs. So what I want to do is, as soon as my EC2 instance, okay, as soon as my EC2 instance is destroyed, I want to remove the logs file, okay, and I don't want anything inside that. So useful, the use cases could be your cleanup scripts, okay, and your backup triggers. Let's say whenever you want to delete a resource, you want a backup of some of the important files, and you have placed a trigger over here. So this can be helpful in that case also. So after your deletion, what will happen? The backup will trigger and it will back up all your important files and information. Okay, and I've taken an example of logging the deletion events, right? So even though these provisioners are useful, like we have seen over here, that local exec is also useful, remote exec is very useful, and file provisioner are also useful when it comes to copying your artifacts, important artifacts, or your SSL certificates, or your configuration files. So even though these provisioners are very useful, but why do you think that provisioners are considered an anti-pattern? Why? Because Terraform is basically designed for infrastructure provisioning, not configuration management. So provisioners introduces problems like non-idempotent. Okay, you can Google this. What is idempotent? And also, let's take an example where Ansible is idempotent. Okay, so learn about it. What is idempotent, and you will be easily able to understand what is the concept and why anti-patterns exist in Terraform. Okay, now it may have some hidden dependencies as well, and it's very difficult to debug, right? It's very difficult to debug because if anything goes wrong, then you don't know like how to debug it inside your remote machine, or even if you are running a local provisioner, then the debugging could be very difficult because in that case you are running the commands onto your local, and your real life um, logs or your real life errors or issues cannot be seen over there. Okay, now also you have one more issue, which is the environments get inconsistent. Okay, and the fragile automation could be fragile, right? So let's understand the example issue where if a provisioner fails halfway, what will happen? Your infrastructure is created. Okay, if a provisioner fails halfway, infra is created. Okay, and configuration is incomplete, right? Your infra is created, but the configuration which you wanted to do over there is incomplete, and you have state inconsistency as well. Okay, so let's say you are relying on to a particular provisioner, let's say Remote-Exec, and what you are doing is you are just installing some of the important applications or maybe some dependencies, and it fails halfway, right? It failed halfway, and what happened? Infra is created, but your configuration was incomplete, and you have automated all these steps using a CI/CD pipeline. Then in that case, if the configuration is incomplete, the next step in your CI/CD pipeline, right, in your CI/CD automation, the next stage would be requiring those configuration, and you don't have it, then in that case your pipeline will fail, and it will be a really difficult task to debug what actually happened. Okay, your state inconsistency is also there, and new Terraform cannot safely recover. Okay, so what are the alternatives for it? Like, you are saying that provisioners are very bad and it is an anti-pattern in Terraform, then what are the alternatives? Okay, I can say this is also a best practice to use. So what you can do, you can use user data instance instead, sorry. Okay, so it basically runs at the time of instance bootstrap, which means whenever your instance is getting up, then only it runs. You can use cloud init. Okay, and the purpose is if you want to initialize the Linux, sorry. You can use Ansible, which is the best tool for config management. So this is considered the best tool in the market currently for configuration management. Okay. Now you can also have Docker, which will basically containerize your apps. Okay, cool. So the example of using user data instead of Remote-Exec could be, let's say you created a resource. Okay. So I'm taking this example why it is better than Remote-Exec, and you have defined your AWS instance over here. And what you do, you have also defined the resource name. Let's say the example is the resource name. You provide your AMI ID, okay, and you have provided your instance type, uh, something like t2.micro or t3.micro. And what you do, you provide a user data value where what you do is basically you add some configuration logic or some shell script. Okay, you can add a shell script, right? And what you can do is you can say that apt update, okay, or maybe sudo apt install, and your whatever configuration you want to do, you can make in this shell script, and you can end this end of file, and you can close this, right? So this is a better option than using a Remote-Exec, right? And we have understood why. Okay, so this user data will be much more cleaner, right? It can be also repeatable, and it is also production ready. Okay, so when provisioners are acceptable in real world, we must use provisioners only when no alternative exists, right? No alternative exists, then only we should use provisioners. Okay, you want a quick bootstrap of your resources. Okay, and if you think that your script is going to run only once, then only you should use the provisioners running one-time scripts. One more thing is, if you want to trigger some external automation, then also provisioners could be helpful. Okay, and where you should avoid them, where you should avoid them, you should avoid them at the time of application deployment or config management. If you really want to uh, do the config management, then what you should use? You should use Ansible. Okay, and package at scale. Installation at scale. If you want to carry these things out, then you should not use the provisioners. Let's take an example code and understand how provisioners are used. So over here inside lecture 12 folder, I have a Python application. Okay. So I'm just creating an application where I'm just saying that, hello, welcome to my channel DevOps Forge, and I'm using Flask, and the host is 0.0.0 and the port is 80. Correct? The next thing which I have is the key pair file so that I can SSH into my instance. The other way is like this is the one way where I've created the file through AWS console and then I've stored it into my local. But you can also use SSH keygen to create your key pair file and then use it inside your main.tf file, your configuration file, so that you can SSH into your instance. Correct? Now let's create a main.tf file, and I will say provider is AWS and region is US, US East 1, right? I will just quickly spin up a simple instance resource AWS instance, and I will keep the resource name as web server. Okay, so web server is the name and AMI ID. So as of now, I want to take an Ubuntu machine. So let's go over here. Let's launch this instance and go into the AMI images, right? It's loading. So this is the one I want to take, Ubuntu machine, and I'm just going to copy this AMI ID Let's paste this over here. Next thing is what I want to do is I want to say that instance type would be t3.micro, correct? And the key name which we are going to use is Terraform examples dot, okay, examples only, right? So this is the one which we are going to use. Now let's quickly do one thing. I will say I will use a provisioner called file, and what I'm going to do over here is I am going to copy my application file into my remote machine. Okay, the source is app.py, right? Because it has in the source directory we have it. The next thing I want to provide is destination, and the destination will be /home /ubuntu and /app.py. So it should copy this file over here. Next provisioner which I want to use is I want to use Remote-Exec so that I will install some of the dependencies which are actually required to run my application. Correct? And for this, there is one important part which I want to mention is from newer updates, you cannot directly go and install Python packages or pip packages, right? So for that, what we need to do is we need to use virtual environment. Correct? So to use virtual environment, let's do one thing. I will add the inline commands. So inline means inline commands I'm going to add which are going to run into my machine, my remote machine after the resource is created. Okay, I will say sudo apt update and -y. So -y is basically what uh, it is an auto approval step, and it is widely used in automation, right? So it will not prompt the user to actually go and approve or say yes or no to update the packages. The other thing is sudo apt inside the quotes sudo apt install. Okay, and I'm going to add the pip package. So pip is the package, and I have to add it while my virtual machine is activated. Okay, now next thing what I'm going to do is I am going to basically create a virtual environment python 3 -m and going to activate it as well, and home /ubuntu /vnv, right? We have everything. Now what we want to do is we want to install Flask as well so that my application can run. Okay, so I'm going to add this inside bin and pip. Okay, so this is the command for it. Next thing is I think this is enough, and we'll go and SSH into our instance after the instance is created and then start our application. Okay, so from where I'm using this command, actually I have this already with me, and I'm taking the reference from there, and I'm using these commands so that the packages get installed quickly. Now next thing, we have used Remote-Exec, we have used file. The other thing I want to use is provisioner Local-Exec, and over there I'm going to do a simple thing, which is what I'm going to run a command and say that echo, okay, echo ec2 public id is, and if I remember it correctly, it was self.public IP. Yeah, it was the one. So this will run locally and it will give me the public IP. And now what I want to do is to copy my file and to make the remote execution of all of these commands so that the dependencies got installed. I need to add a connection, right? We have seen in the example, the type will be SSH, it is auto completing. Next is user, and our user is Ubuntu, correct? Now private key, I will use the file command to use the file, right? We have seen this before, and the file name is, we know very well, Terraform examples Okay, I must not mistype it. Examples.pm, PEM. Okay, I think it's correct. Terraform hyphen examples.pem. Cool. And the host is self.public IP, right? So the public IP of the instance will be used for SSHing into my instance. Okay. Now next thing is I'll do one more thing. I'll quickly add a tag and say that the name of my EC2 instance would be Flask app server. Cool. So we have every information. Okay. One thing we have missed over here is we need to add security group as well. Why? Because whenever you are trying to SSH into your instance, you need your 22 port to be open. And other thing is we are using port 80 over here, right? For our application. So to access our application, we need those ports to be open. So already what I have done over here is inside the default security group, if you go over here and inside this default security group, I have added the port 80, right, for HTTP and for SSH 22. The next thing what I'm going to do is I'm going to copy the security group ID and say security group IDs. Inside this string, I'm going to provide the value of the security group ID. Okay, now quickly initialize the backend. Let's wait for some time. So you understood very clearly that we actually require security groups so that the Terraform or we can access to our application or run our application, and also the Terraform can SSH into your instance and copy the dependency files, copy your application file, and then also execute your application. Correct? Now we have 4 permission entries over here. All of them are there. If you use HTTPS, it would be fine. But since we are using port 80 inside our application, then we're going to use HTTP as our protocol. Okay. We are not going to use 443. I've just given this example how to add a port inside a security group. Now I think it is initialized. Next thing I'm going to do is I am going to apply the changes, and I don't want to get prompted in between for yes or no. So I'm going to use a flag called auto approve, right? And see, I have not been prompted to say yes or no to create my resources, and it is creating my resource. These are the information which I have, and one by one what it will do, it will use these provisioners and execute this, and you'll be able to see all of that into the terminal itself. Okay, just waiting for that to happen. And yeah, the first step, it is provisioning the file, right? Now let's wait to web server be created, and I hope we didn't make any mistake. So we'll go through that once again. The file, we have providers, we have our EC2 instance, the AMID is correct, it seems to be correct, right? Okay, over here, see very clearly, you have some steps mentioned. So user is Ubuntu and password is false, right? We haven't used password. We were using private key, which is why private key value is true over here. And using that private key, the Terraform will be able to SSH into my instance. Okay, now checking host key. So these are things which we don't require to understand. And inside the Remote-Exec, you can see over here it is running. And inside this Remote-Exec, all the commands which we have given over here is running. Okay, it is creating the virtual environment. Okay, it is updating the packages. It is installing pip, and it is also installing Flask. So these all executions are happening over here. Okay, let's go down and let's see the next step. Yeah, I think most of it is done, and Local-Exec is also executed, and it says that EC2 public ID is 44.204.90.137, right? We have used this command to print Okay, echo EC2 public ID is, and you can see that clearly over here. Let's go to our console and match our ID, instance ID. Okay, I will go to, okay, over here only. We'll go to instances. I will set the state to running. And yeah, Flask app server. This is the tag which we have added. It is up and running. Inside this, 44.204.90.137. And this is the exact same ID which we have seen in the terminal as well. Okay. Now I will do one thing. I will actually connect to this instance using the instance connect. Okay. And let's run our application so that we can see it on our browser. So let's wait for till the time. Okay. Connection is established. Now I'm going to run a command. Okay. Sudo home Ubuntu. So inside the home, what I want to do is, while the virtual environment is activated, okay, I will run my app and I will say home Ubuntu app.py, right? So this is the command. Let's copy it because I want to show you one more thing. I've copied this and let's paste it over here. So you can see inside where we are actually inside the home directory, and inside this what we have app.py, right? And this is what we have provided inside our destination, that I want the app.py to be copied inside this folder, isn't it? So which is why it is present over there. Now quickly run our application and let's hope it's working. Okay, so the server is activated. Now let's do one thing. I'm going to copy the public ID and let's say HTTP. Okay, yeah, you can see, hello, welcome to my channel DevOps Forge, and our application is active now. So this is how you use provisioners, and you can have different types of provisioners by which you can automate your deployments, or you can install some dependencies or some configurations. Let's understand how to debug and troubleshoot Terraform issues. When working with Terraform, errors are normal and expected. What makes anyone advance is knowing how to debug them quickly and safely. In this section, we are going to cover how to enable debug logs, how to investigate provider errors, and how we can resolve the state conflicts, as well as how to recover from failed applies. Okay, so let's start with the first one, right? So what I will do is, I will go to the code and actually run the command. Okay, and let's see how we can debug our logs in Terraform. So Terraform provides internal logs that show what's happening behind the scenes. So the command for it is tflog equals to debug, and then you say Terraform apply. Right over here, you can see it is saying that what is your Terraform version, right? And it is debugging and giving all of the logs which are required for debugging, right? From here, you can understand what is the issue going on with your configuration file, and you can resolve it by going through all these logs and understanding what is happening inside your configuration file, right? So this was the first way to debug. Now let's move ahead with the another command, okay? And which is what you have a command called tflog equals to trace, right? So when do we need it? When we want most detailed logs, then we use tflog equals to trace, and let's hit enter and see you have n number of debugging statements going on. Okay, so it is basically tracing all of the values over here, all of the configurations, and you can see a detailed log over here, right? So this is the another way. Now let's move ahead with the another example, and let's say if I want some info, okay, so if I want some general execution info of my configuration file, then I will provide tflog equals to info. Let's hit enter, and you see there are some information that the Go runtime version is this, your Terraform version is this, right? And another set of information which you require to understand what all the information your configuration file consists. Okay. Now, if you want some warnings, if you want to see that there are some warnings or not inside your configuration file, then simply replace this command with warn, and it will show you all the warnings that are coming up with your configuration file. So what it is saying is provider registry.terraform produced an invalid plan for AWS VPC.main, but we are tolerating it because it is using the legacy plugin SDK. So these type of warnings you can identify, right? And this is helpful in the case where, let's say, right now this AWS VPC.main is getting supported in this particular version 1.14.7 of Terraform, but in the next version, if it will be deprecated, right? This is an example. So this warning basically also gives you the information that in this version it is getting supported, but in the newer version it may be not. Then in that case, what you can do is you can plan your upgradation, or you can plan your upgradation of your or updating of your Terraform configuration file, so that in the newer versions your configuration file should be supported, right? Which is why this warning is very helpful. Okay, now moving ahead with the next command, and I will go over here. And if you want to see errors only, right, that what errors are your configuration file throwing, then you just put error over here and you will see something. Let's see what will happen, if there are errors or not. So if there are no errors, that is why it is not showing any error. If it would have any error, then it can be seen in the terminal very clearly. Okay. Another thing is, what you can do, you can store your trace file. Okay. You can store your trace inside a file, right? And how to do it is, I'm going to say df log path, right? And I will say terraform dot log. So inside this file, store all of the traces which you are capturing from this and store in the terraform dot log. I will hit the enter and let's see what will happen. Okay, so if you see over here, right, you have all the logs present, and if you want to store it and then watch it, because sometimes what happens is your terminal will not be able to show you all the traces. Okay, because there is some limit of history which you can see, and in that case what will happen, some newer logs will be, or newer traces will be only seen. For example, let's say from line 720 to 10,000 or 2000, till that time only you can see. Then in that case, what you can do, you can store this into a log file and you can see a detailed version of your traces. And this is very helpful when you have a very big infrastructure, and or you are using any CI/CD pipeline to provision your infrastructure. Okay, so these things are very clear, and the best practice which we follow is you should use debug normally and trace only for deep investigation, right? So I think we have understood the first one very clearly, how to enable debug logs. Now let's move ahead with the investigate provider errors. Provider errors occur when Terraform cannot communicate properly with your cloud provider like AWS or your Azure or GCP, right? So what would be the error example could be, like if you are getting some provider errors, so the Terraform will throw an error and say that it is an unauthorized operation. And what could be the possible reasons? First is you must have passed wrong credentials or maybe stale credentials. Second could be expired tokens, right? And third could be missing IAM permissions. Okay, maybe the user who is trying to apply the changes does not have permission to apply it, right? And also you may have provided some incorrect provider configuration, right? So the example fix is, First, check the provider block. If you don't have any incorrect provider configuration, then only you should move ahead with the next step, which is what you want to verify the credentials, right? And how you can do it in AWS, you can hit the command AWS configure and you can see that your credentials are correct or not. So first fix the provider configuration, then only move into the second step. Okay. And or you can also check the environment variables where you have set your access key ID or your secret access key ID, right? And always confirm provider authentication before debugging Terraform code, right? So the second point is also we have covered. Now let's understand how to resolve state conflicts. Okay. Terraform state keeps track of infrastructure. Sometimes conflicts happen due to manual edits, okay, manual changes, right? Or parallel Terraform execution, Terraform execution, or maybe your state is corrupted, or somehow the deleted resource is there outside Terraform, which means outside your state file, right? So these conflicts could happen, okay? And the example error could be your state is locked, right? Then in that case, in the state lecture where we have explained that how to store your state or what is the Terraform state, right? In that lecture, I have explained one command by which you can force unlock your state, okay? And let's say your state is stored in S3 and the lock is stored in DynamoDB, and somehow the lock you have the flag you have provided over there is locked. Then in that case, you can use Terraform force unlock and the log ID, right? So this is the one way how you can resolve the state conflict. The other way is you should refresh your state, right? And the command for it is Terraform refresh, right? So the best practice is never manually edit state unless absolutely necessary, right? Now fourth is how we can recover from failed applies. Okay. Sometimes Terraform apply stops midway. In that case, what will happen? Your infrastructure will be created partially. So what are the recovery steps? Okay, recovery. First step is run plan again. Okay. So Terraform detects missing resources automatically, which is why we should run plan again, and it will come back to the state where you want it to be, right? The second point is you should apply again, and Terraform will resume safely from last successful state, right? Third recovery step is if resource exists outside Terraform, what you can do, you can import it in your state file, okay? So in the playlist of Terraform interview questions, I'm going to explain how you can import your resources which are outside your Terraform file, which means which are not created by you and is created manually, and you want to import it into your state, right? This is a very important interview questions and are asked. This is asked many times into the interviews. So I will cover that in that playlist. For now, let's move ahead with the next point, which is if state is corrupted, then what you can do, you can use Terraform state pull, okay? And it will pull the latest state and then push the corrected state, okay? By using the command Terraform state push, okay? And I guess the state file name, tf state, right? So pull the latest state, okay? And then push it if your Terraform state is corrupted. Okay, now how we can debug our workflow in the real world. So you should follow this order, which is real world debugging. First step is read error message carefully. By using the enable debug logs, you should read the error message very carefully Second is run Terraform validate. We have also covered this. Go and watch that video. Third is you should run Terraform plan. I've always suggested you to run the Terraform plan where you can see what all resources are going to be created, what are going to be destroyed, or what are going to be updated. Okay. Next is you should enable debug logs. Why? Because it gives you the detailed information of what is happening inside your configuration file, what is going to fail, and what is stopping it to be created successfully. Also, check provider authentication, right? And now the sixth step is inspect your Terraform state file, which is very important. Okay, so this solves 90% of Terraform issues quickly. In the next video, what we are going to do is we are going to create a simple project on AWS so that you will be able to understand how you can provision your resources or how IT companies are using a simple project or basically how they are creating a simple project. And if you like this content, subscribe to my channel and we will meet in the next video.